yeah, I'm about to fade away. Cause every time I wake up I feel like it's Monday. Something's going wrong with all the chemicals up in my brain. All of a sudden I don't look at anything the same way. Gotta build up of my thoughts sitting in an ashtray. I'm sorry that I'm so inconvenient, okay. Just let me be me and I'll stay out of your way. I can see the way you look at me, I'm such a disgrace. I never really asked to be brought into this place. You wanna love me? Well then baby, have a taste. All the highs and the lows, no you'll never be the same. I don't really wanna hurt you, but I can't control the pain. If you're sticking by my side, maybe we could be okay. Okay, maybe you could be the change I need today.
Already mic testing. Okay, perfect. Let me go to my main camera. Already we're live, and as you guys can tell by title and thumbnail, today I'm going to be working with, let's say, more Scikit-Learn under the section or under the category of, let's say, math and machine learning there. More specifically, I'm working with, let's say, I forgot what was the name of it. I think it was like classified math and machine learning while working with, let's say, I think it was forestries. Okay, that said, let me go to my gameplay screen. Hold on, I forgot the name of the topics. What the hell? Even though I literally just saw them. Wait a minute. There we go. Okay, so apparently last stream I did work with, oh, there we go. Last stream I did work with regressions, a little bit of regressions. And then I completed my random forest. I was about to complete, let's say, ridge regressions last stream, but then I did sort of kind of stop because I got too exhausted. Although today I will be completing ridge regressions and then moving on to clustering and hopefully even dimensionality. And then maybe next stream or by the end of that stream or 2 streams later, I will be working with, let's say, model evaluation. Okay, for the time being, I will be following a 25 to 5 minutes Pomodoro as well as usual, starting in 3, 2, 1, and let's go. And I just forgot, I hope my mic wasn't too away from me. There we go. Okay, let's say something like, let's say I'm live exclamation. And yeah, this is a brand new clauses chat. And I will be playing some Wuthering Waves in my break time as well. Okay, let's see. There we go. Okay, let's go. Alright, quick gut check before we move on, because last time you tapped out mid-explanation, not mid-confusion. That matters. You understood the huge weight equal to red flag. Okay, I did, but I still need to get a little bit warmed up. Okay, peace when I said it. The question is whether it's still sitting there today or if it's evaporated overnight. And so no pressure, no penalty for either in your own words. Why is huge weight, which is coefficient, a red flag for modeling? Okay, let me say something like, my brains are not, let's say, warmed up. Therefore, can I get the explanation EXPLANETIO, and can I get the explanation as a refresher? Okay, and hold on, I think I need to add a comma here. And today were we going to let's say work with ridge regressions question mark? Hold on, RIDGE. There we go. And yeah, I will be touch typing today as well. That's it. Let's see. Good, that's exactly the right call. And exactly what you're supposed to do when you're cold. Not guessing, not faking it, just flagging it straight. That's the moves. Here's the refresher, no penalty attached. Why a huge weight is a red flag. A weight coefficient tells you how much the model thinks one feature matters. A huge weight means the model is making an extreme overconfident claim. This one feature swings the prediction a lot. I see. Yo, howdy Philip here. Appreciate you joining the stream. I'm back. Let's go. Okay, wait. A weight coefficient tells you how much the model thinks one feature matters. A huge weight means the model is making an extreme overconfident claim. This one swings the prediction a lot. I see. Okay, the problem, extreme claims like that are usually the model latching onto a coincidence in the training data, not real, stable pattern. Real relationships in the world tend to be moderate, not extreme. So when you see a massive coefficient, It's usually the model saying, I found something huge, when what it actually found was a noise that happened to look huge in the specific dataset. Okay, is your name Vivek? It's actually Vivek. You know what? Screw it. I can type it for you in chat. Okay, it is. There we go. Okay, that's it. That's the whole motivation of Ridge. We want to punish huge weights, so the model is forced to say moderate and reasonable instead of chasing coincidences. And yes, today's the day. We're picking up Ridge regressions exactly where we left off. You already have the why, overfitting, weights, huge weight, red flag. What's not taught yet is the mechanism, the actual penalty term, how it bolts onto the loss function, and what keeps weights small. Looks like in real math and real Ridge code. Okay, I see. Does loss function itself feel solid? Let's see. I mean, actually, can I get a real world example as well? Question mark. I already got it right here late. There we go. Let's see. Oh wait, why did I add a question mark there? Okay, good instinct. And yeah, the reason I didn't understand that was because I'm not warmed up just yet. Okay, good instinct. Asking for that up front instead of nodding along and losing it later. Real world example of a huge weight being a red flag. Say you're predicting house price using features like square footage, number of bedrooms, and the house number on the street, like 742 versus 12. House number is meaningless. Okay, say you're predicting house prices using features like square foot, number of bedrooms, okay. House number is meaningless, that's basically random. But let's say in your small training set by pure coincidence, the expensive house happened to be the house numbers. Like they were all built later in a new phase of the, let's say, neighborhood address 700 plus. A model that overfits might assign house number a huge weight. Because this trading data, it happens to correlate with prices. Wait, actually, hold on. The model gets excited, big house number, big price, but that's not a real pattern. That's a coincidence. Take that model to a new house. House 5, that's actually a mention, and that house tags the prediction because it built its confidence. Wait. A well-behaved model would give house number a weight near 0 because deep down it's irrelevant. The house weight is the tell that the model got fooled by. Noise instead of learning. Oh, okay. The real signal, square footage, bedrooms, things that actually casually drive prices. That's the danger. Ridge is designed to guard against. What causes a model to have a heavy weight? There we go. Okay, and then I'm just gonna go ahead and send it. Okay, sharp question. That's the right thing to be digging on, blah blah blah. Okay, you can't understand, keep weight small until you understand what makes them big. What actually causes a heavy weight? Remember the dot fit? Yeah, this is the method that sort of adapts to any of our functions that we're trying to train. There we go. And it trains or it changes its training methods based on what the function really does. That's it. Remember dot fit for linear regression? We used gradient descent, right? It's gradient descent, just adjusting weight step by step to minimize errors. Gradient descent basically uses logical steps to decrease the size of the error. There we go. On the training data, that's the only goal it's chasing. It does not know or care about the real world or new data. It only sees the row in front of it. So, here's the mechanism. If a feature happens to line up really well with the target in that specific training set, even by coincidence, the model realizes if I crank this weight up high, my error on these exact training rows drops even more. Interesting. Oh yeah, so it keeps getting the weight higher, so the errors get lower and lower. They don't have a limitation. Gradient Descent's whole job is to keep chasing lower error. It has no built-in reason to stop at a reasonable weight if cranking a weight higher and higher keeps shrinking the error on that training data it can see. It will keep cranking it because nothing is telling it, hey, that's excessive. Going back to the house number example, if by coincidence high house numbers equals to high price in that training set, gradient descent finds that pushing the house numbers is weight higher and higher keeps reducing the training error, so it keeps pushing. Nothing stops it. It has no concept of this is a coincidence. Back off. In one line, heavy weights happen because gradient descent is only optimizing for training errors, and it will exploit any patterns, real or coincidental, as hard as it can because nothing is penalizing it for going extreme. I see. Okay, that nothing is penalizing it gap is exactly what Ridge fixes. Ah, I see. Ah, I see. Okay, let's go with something like I see, and my brain is about let's say 83%. I'll go with something like 83% warmed up. Okay, because that explanation really jogged my memory from last stream. 83, I'll take it, that's enough to move. So you've now got the full picture leading into Ridge. Gradient Descent only cares about minimizing training errors. It has no brakes. It'll push a weight as high as it needs to. If that keeps shrinking the training error, huge weights are often chasing coincidences, not real patterns. That's overfitting and it keeps performing on new data. Now, here's the actual fix. Ridge regressions change what gradient descent is even trying to minimize. Normal linear regressions' losses. Hold up. Normal linear regressions' loss function is just loss equals to error. How wrong the predictions are. Ridge's loss function adds a second piece. Loss equals to error plus penalty for having a big weight. Oh, I see. So basically, ridge regressions are a cap for gradient descent, which linear regressions really use to kind of not let the weights go really high. That's going to make the model overconfident. Okay, so now gradient descent isn't just asking, how do I shrink error? It's asking, how do I shrink error without letting weights get huge? There we go. I remember this from last stream. Because huge weights now cost me too. It's forced into a trade-off. If a weight wants to grow big to chase a coincidence, it has to be worth it. The error reduction has to outweigh the penalty for now. Wait, the error reduction has to outweigh the penalty now it pays for being large? Quick gut check or quick check before I show you the actual math of that penalty term. Does the loss function now does the loss function now has to what? Does the loss function now has two competing, there we go. Oh god, I messed up the 2 with 2. Now has two competing parts, minimize error and minimize weight size. Does that make sense as a concept first before we move on to the formula? It does. Okay, I guess let's move on to the formula now. Okay, good, let's put that actual formula in front of you. You said it yourself, blah blah blah. Okay, so apparently ridge regressions' loss function. Loss is going to be equal to sum of actual minus predicted to the power of 2. Loss alpha multiplied by sum of weights to the power of 2. Break it into 2 pieces. Piece 1, sum of actual minus predicted to the power of 2. This is the same error term from regular linear regressions. Nothing new, it's still measuring how wrong are my predictions. Interesting. Piece 2, alpha multiplied by sum of weights. Isn't alpha like opacity? This is the new part, the penalty. Let's break that down. Sum of weight to the power of 2 takes every weight the model has, squares it, and adds them all up. So we square our weight first. We add the squared weight up. Sum of weight to the power of 2. We get the power of 2 and then we sum it. Interesting. Okay, squaring does two things. It makes everything positive and makes big weights hurt disproportionately more than small ones. A weight of 10 squared is 100. A weight of 2 squared is only 4. Okay, so this term punishes large weights hard. Alpha, a number you choose before training. This is what's called a hyperparameter, a setting you pick. Not something the model learns. It controls how much the penalty matters. Interesting, okay. Oh, I see. I don't really see, but I think I see. Quick gut check on alpha specifically once it's a brand new. If alpha equals to 0, what do you think happens to ridge? Does it behave differently? Okay, it will have 0 weights. Okay, let's say something like 0 weights because anything multiplied by 0 equals to 0. Okay, I think I'll rely someone writing the code first to like see if I actually get it. Close on the math instinct, but let's check the logic. You multiply the right thing, just landed on the wrong target. If alpha equals to 0, look at what actually becomes alpha multiplied by sum of weights. The whole penalty becomes 0. Huh. Not the weight themselves, the penalty term disappears, so the loss function becomes 0. Loss equals to error plus 0, which is just a regular error, no penalty at all. Oh, I see. So think about what gradient descent does now. If there's 0 cost of having big weights, what's stopping it from cranking weights up like it did before? There's 0 cost of having big weights. What's stopping it from cranking weights like it did before? Oh, wait, if there's 0 cost of having big weights, 0 cost of having big weights, nothing. Nothing should stop it. Besides, like, ridge regressions. Exactly right, nothing stops it. When alpha equals to 0, ridge regression collapses back into being identical to the regular linear regression. No penalty, no breaks, a gradient descent chases a training error with 0 regard for weight size. Same or fitting risk as before, that's actually a real useful mental checkpoint. Alpha equals to 0. Is ridge doing nothing? Oh, I see. Nothing different. Ridge only starts actually protecting you once it's greater than 0. Now flip it. What do you think happens as alpha gets bigger and bigger, like alpha equals to 1,000? What does gradient descent get pushed to do to the weights? It gets the weight really big. Wait, does it? Hold on, let me see the formula. Alpha multiplied by, so whatever that thing is, like really big. Let's slow down and check that against the math itself because I think intuition took over here. The penalty term is alpha multiplied by sum of weights. Gradient descent's job is to minimize the total loss, error plus penalty. It's not trying to maximize anything. It wants the smallest number possible. So if alpha is huge, the penalty term becomes massive. The second any wage grows, a weight of 10 now costs a fortune. The second any weight. Wait, hold up. Did I read that correct? That penalty terms become massive the second any weight grows. A weight of 10 now costs a fortune. There we go. That makes sense. That's what I meant by saying the weights. It gets the weights really big. The penalty term is alpha multiplied by sum of weights to the power of 2. Gradient descent's job is to minimize the total loss. Error plus penalty. It's not trying to maximize anything. It wants the smallest number possible, so if alpha is huge, that penalty term becomes massive the second any weight grows. Oh, that makes sense. A weight of 10 now costs a fortune, a weight of 1 costs way less. If gradient descent is trying to keep the total cost small and big weights now make the penalty explode, would it push weights up or would it back off and keep them small to avoid paying a huge penalty? Yo, hiding pixel, appreciate you joining the stream. Okay, wait, let's see. If gradient descent is trying to keep the total cost small and big weights now make penalty explode, would it push? It would back off because the penalty is a lot. Okay, it would back off because the penalty is a lot, and bridge regressions makes sure that the errors are as less as possible without having to have huge weights. There we go, and then let's just go ahead and send it. Okay, that's it there. That's not just correct, that's the actual definition of rich regressions in your own words. Let's make sure you feel that, because you just self-corrected and landed the concept in one shot. As alpha increases, the penalty for big weights gets more severe. Gradient descent backs off to avoid paying it. Weights shrink towards small slash moderate values, and you nail that, and you nail the framing. Ridge isn't ignoring error, it just keeps the weight small. It's a balancing act. Get error as low as possible while being forced to keep the weight small. Neither side wins outright. Alpha controls the tug of war between them. So now you've got both ends of the spectrum locked in. Alpha equal to 0, no penalty, behaves exactly like linear regression. Weights free to get huge. Alpha large, heavy penalty, weights get squeezed small. Moderate model becomes let's say more conservative. That's the whole mechanism. That's ridge regression. Now, real talk. Quick gut check before we go any further. Does alpha is a dial you control? Does alpha is a dial you control, not something the model figures out on its own. Feel solid? Yep, it does. Because that's actually a big vocabulary word coming up, hyperparameter, and I want to make sure it's not just floating there unattached. I see and also understand. There we go, and then let's send it. Wait, what was the problem of big weights again? I kind of forgot. Okay, good, then let's lock in the vocabulary properly. Hyperparameter equals to a setting you choose before training starts that the model does not learn on its own. Contrast that with a weight like .cof underscore that is learned. Gradient descent figures those out by grinding through the data. Alpha is a hyperparameter. You pick it, the model never decides. I think alpha should be 5. You hand it a number and then gradient descent goes and finds the best weights given that alpha. Quick gut check, since it's a new word getting attached to an old idea, was alpha the first hyperparameter you've run into this curriculum, or does that word ring a bell from random forest or decision trees? I have never thought of it that way. However, I had a quick question. There we go. I understand what ridge regressions do. And let's say something like, and weights and huge weights equals to red flag. Okay, let's go with something like, but something that I am still, let's say, something like, I don't know, confused about is the fact that why are weights a red flag? Okay, let me say something like, I know that you literally just answered that question. However, I kind of forgot. Okay, there we go. What happens when a weight is too high? Like the consequences. There we go. I think I spelled consequences wrong. Hold on, let me fix my typo real quick. It's fine. Glad we'll understand it. That's it, good. That's you catching yourself instead of faking through it. Exactly the notes on you say that deserve blah blah blah. Let's trace the actual chain of consequences step by step using the house number example. Step 1. In your training data, house number happens to correlate with price. Pure coincidence. Step 2. Gradient descent with alpha equals to too low equals 0 or too low. Notices if I make house underscore numbers weight huge, my training error drops. So it does it. Step 3. Now the model has essentially memorized multiply house number by some giant number that's basically the price. You bring in a new house, one has never seen, house 5, a mansion. Step 5. The model plugs house number 5 into its formula because the weight is a huge. That tiny house number gets blown way out of the proportion in the prediction. The model splits out. Alright guys, hold up. I'm going to read this in a bit. That's it. Hands off anything that is distracting. Time for break. Time for break. Moving on to Wuthering Waves. Yo, hiding observer. Appreciate you joining the stream. I forgot what we were working on last time in Wuthering Waves, and I hope that I don't have my let me try to decrease the size. There we go. Whoops, hold up. There we go. I want to make sure that I don't freaking mess the timer up again, and I want to make sure I don't have my blue light filter on because I think I have it. No man, I don't. Okay, good. Is this like genuinely this dark every time? So it says continue investigating the skyworks and catching up with the suspects. Where do I go? Apparently here. I forgot where I stopped last stream. Okay, P to quit. Do you wish to quit the challenge? No. I want to go in. Defeat the auto puppets. I don't see anyone. I am so confused. Where do I go? Wait, do I need to push something? I'm just gonna walk here a bit because I'm pretty sure I need to like push something, right? I remember doing... Oh, wait, do I need to use like a skill? Should I just quit this? I don't know what to do here. Weren't you coding a couple of minutes ago? Actually, I was, but it's currently my break time. I am following like a 25 to 5 minutes of Pomodoro break. Where are the auto puppets? Wait, is it this? Is this something? White Jade. Oh, there we go. Okay, there. Oh my. There they are. There they are. I can't see squad. It's so dark. Hold on. There we go. Well, they're not as strong. They're level 89. Are there more auto puppets? I don't see anyone though. What kind of challenge is this? Oh, there we go. There they are. Oh wow, he's level 90. He looks more like a Tacit discard to me than an auto puppet. Checkmate. I don't really like Rover's animations. Like, he gives me the vibes. Like, if you guys ever played Solo Leveling or Rise, the game, he reminds me of Sun Jinu from there. But here's the thing. Now that game is $40 to actually play. Oh my, oh god. Down with the curtain. Interesting. Okay. Oh, we're rescuing people here. I lost the context here. How were you captured? Why did I have my desktop audio on? Oh no. That's fine.
And it wasn't just us. They seem to have seized folks from all over these lands.
Alright.
Demons take him. What's that man plotting?
Is there anyone else trapped here?
Oh, yes, you must hurry. They've been taking people deeper into the factory, and no one ever comes back.
We will do everything we can.
Alright. Okay, so apparently we're going... Oh, wow. Oh, wow, we get 5 asteroids. Recaptured action highlight. Layman recon acid prices. I peak off... Oh, God, what are those awards or something? Also, I kind of forgot. I wanted to go to events and see all the new events. Maybe my next break. Ah. Oh. 19 seconds. Oh, wow. I want to proceed to all these things. Is there anything free to claim? 12 seconds. Oh, wow. They're giving a lot of airstrikes there. I'm gonna come back to them all. Wow. A proceed trial. I don't know. Alright, guys, that's time. Hands up anything that is distracting. Moving on. Back to work. There we go. Guys, I'm gonna look into this in my next break. I was just basically grinding out the story. I needed to like look at the events. I haven't claimed anything since yesterday. That said, good that you're catching yourself instead of faking through it. Exactly like the notes on you say. This deserves a real answer, alright? Okay, I think we were on these steps, right? The consequences. In your training data, a house number happens to correlate with price. Pure coincidence, okay? Gradient descent with alpha equals to 0 or too low notices. If I make house underscore numbers as weights huge, my training error drops. So it does. Step 3. Now the model has essentially memorized multiply house number by some giant number that's basically the price. Step 4. You bring in a new house, one it's never seen before. House number 5, a mansion. Step 5. The model plugs house number 5 into its formula because the weights is huge. That tiny house number gets blown way out of proportion in the prediction. The model spits out a price that's widely, obviously wrong, way too low because it's learning almost entirely on feature that never actually mattered. Okay, that makes sense. The consequence, in one sentence, the model makes a garbage prediction on a real wrong data based on coincidence, even though it looked accurate during training. Oh, I see. That's the actual cost. It's not that a huge weight is wrong while training. It can even look perfect on training set. The danger shows up later on data when that inflated trust is a coincidental feature gets exploited as fake. I see. I think that I will understand it better later on when I get more practice. However, for the exposure of it, I think that I understood. Okay, the thing that I'm clearly missing is some hands-on practice, which I will be getting later on. Okay, that's a completely fair place to land, and it matches the pacing philosophy you've been running this whole curriculum on. You're not chasing mastery on first, you're chasing real exposure, so the concept has a hook to hang future practice on. First pass exposure, not first pass mastery. That's the deal. So let's tell you what you've got solid from today. Ridges' loss. Error plus alpha multiplied by sum of weights to the power of 2. Alpha equals to 0. No penalty. Same as linear regressions. Alpha large heavy penalty. Weights get squeezed small. Ridge is a balancing act between minimizing error and minimizing weight size, not one winning outcome. Alpha is a hyperparameter. You said it, the model does not learn it. The consequence chain, coincidence in training, huge weight, looks great on training, falls apart on new data. That's real exposure, blah blah blah, okay, all that basic stuff. Next up is where this becomes real. Writing actual rich code from Scikit-Learn, seeing the alpha parameter live and comparing its .cof underscore, which is basically coefficient, output against plain linear regressions as coefficient output on the same data. So you see the weights shrink happening, not just hear about it. Yeah, I am. Let's go with something like ready. Okay, while I really say that, I'm gonna kind of grab my Visual Studio Code up here. There we go. And just curious, is my recording still going on? There we go. Okay, let's see. I'm just gonna exit Visual Studio. And yeah, this is the code from last stream. I haven't like touched it. Well, this is the code from last stream. Okay, ready for the code. This is where it stops being abstract. Quick check first, since this is new syntax. You know the rule. Have you ever used Ridge? I have not. I love the fact that Claude always asks me if I've used something before I really work on the code. If I did, then I just write it. If I did not, then I get an explanation and then I write it. Good flagged. Ridge, the real thing. You already know linear regressions from Scikit-Learn, I do. Ridge works almost identically first. .fit, same .fit, same .predicts, same .coef. With one difference, it takes alpha as a hyperparameter. We just spent this whole session on. Interesting. So from Scikit-Learn.linear underscore model, I want to import ridge, and then I create a models as variable. I set that equal to ridge, which has an alpha of 1, which is a really small number, so my error could be really high. Or my weights could be really high. Model.fit. Fit is an adaptive method which trains based on what function my variable, let's say, consists of, if that made any sense. X and Y, that's my datas. X is my data, Y is my prediction. That's it. Alpha 1.0 is just a starting value. You could put alpha 0, alpha 10, alpha 1000, whatever you want to experiment with. Here's the exercise, and remember our rule. You write it, run it yourself, send me the real code and real output. I don't run it for you. Your task? Use the same weather data set you already have from decision tree / random forest. Temp plus sunny flags, played outside or whatever XY setup was. Actually, quick pause. Since ridge regression is not classification, your weather dataset predicted a yes / no. Played outside, which was a classification. Ridge needs a numeric target to predict, not a category. That makes sense because logistic regressions as opposed to linear regressions, it gives me, let's say, a category. Either pass, either fail. Before I hand you the exercise, do you have a regression data set already sitting around? Or do you want me to give you a quick fake data set? I mean, let's say a quick fake data set would be something new, because I have been using the same data set for a couple of streams now. Let's go with something like for a couple of streams now. Okay, and then let's just go ahead and send it. I guess we're working with a new data set here. Okay, good call. Fresh reps on new data are actually better for testing whether you really get it versus pattern matching on a dataset you've memorized. Here's a small fake dataset predicting a test score based on hours studied. Oh wow, we're gonna be using NumPy? Wait, I remember I did install NumPy. I haven't worked nearly as much with it though. From Scikit-Learn.linear underscore model, I want to import ridge. X equals to numpy.array, which is going to be having a list. list that consists of values. Y np.array, this is going to be a prediction, which is going to be a list of numbers. Simple numeric target test score, one feature, hours studied, clean regression setup, your task. Type this dataset into your file, don't copy paste, type it. Builds muscle memory, that does make sense. Create a ridge equals to a ridge alpha equals to one model, fit xy, print coef, and dot intercept. Before you run it, predict, do you think the weight.coef will be a big or a small number given hours studied? Score is a pretty strong relationship. Not a coincidence like house was. Okay. So this is our values. I mean, I believe that the weight will be small because even though the alpha equals to 1.0, let's go with something like equals to 1.0, right? Equals to 1.0. The values in the data set does not go as far as, let's say, 1,000. Okay, therefore, the weights may not go as high as well. Wait, something is wrong here. Something is wrong here. The values data set does not go as far as 1,000. 1,000 would decrease. Wait. No. Will be small because even though the alpha is 1,000, no weight, no limits. No limits as to how high the weights can go. The values in the datasets are pretty small. Datasets are pretty small. Okay, and then let's just go ahead and send it. Let's check that reason carefully because there is a mix-up in there worth catching before you run first. Correction on alpha equals to 1.0, that's not no limits. You already found the two ends. The spectrum earlier, alpha equals 0, no penalties, no limits. Okay, makes sense. Alpha large, heavy penalty, weight squeeze small, alpha equals to 1, so it's a bit wean. It's a real active penalty, not 0 extreme. Wait. Is this like how alpha is in DaVinci, where like we go with 0.5 and all that stuff as well? Second, the size of data values, hours studied being 1 through 8, scores being 50s, 80s, isn't really what determines whether the weight is big or small. The weight represents the relationship between hours and score. Roughly how many points does score go up per extra hours studied? Look at your data going from 1 to 52 to 8 to 85. That's roughly 33 points spread over 7 hours. So, the weight is likely to land somewhere around 4-5-ish. Alright? Here's the real question to repredict on, given that the hour studied score is a strong will consistent pattern, not a coincidence like house number, and alpha is 1 point, and alpha equals to 1.0 is a moderate penalty. Do you think Ridge will shrink that weight down a lot, or a little, or barely at all compared to what plain linear regressions would find? Barely at all compared to, I think it would shrink it barely. However, something that would take care of my, let's say, confusion could be what is, let's say, something like, what is the scaling criteria of, wait, hold on, did I spell criteria wrong? Interesting. Could be, what is the scaling criteria? How do you spell criteria? Certeria. Interesting. There we go. Criteria. What is the scaling criteria of the alpha? Like, is it a scale from 0 to 1, like how DaVinci, what up? It's a software name. DaVinci resolves RGB or alpha is like, actually let's go with something like 1.0 equals to 100%. Let's go with 0.5 equals to 50% and so on. Okay, that should probably answer the question here. Good prediction. Barely is the right instinct for a strong-willed pattern with only a moderate penalty, and that's a sharp question to stop and ask, because if you kept that DaVinci resolve 0 to 1 assumption running silently in the background, it would have caused confusion down the line. Straight answer, no. It's not a 0 to 1 scale. That's totally reasonable guess for video editing, but it's not. But it doesn't transfer here. Alpha in ridge regression is an unbounded positive number. It can be 0, 0.5, 1, 10, 100, 10,000. There is no ceiling, no 100% equivalent. There is not a percentage or a proportion of anything. Think of it like a side capped at full and more like a volume knob. Think of it less like a cider capped at full and more like a volume knob with no maximum. You can always turn it up more, and the penalty just keeps getting more aggressive the higher you go. There's no point where it maxes out at some built-in ceiling. Typically, real-world values people actually use tend to be smallish, like 0.1, 110, 100. Oh, I see. But that's a practical / experimental convection, not a rule baked into the math. Nothing stops you from trying alpha equals to 5,000 if you wanted. Does dropping the scale, yada yada. Ah, I see. Okay, let's say something like, we can work on the code now, which basically means some practical exercise. Let's go, you've got the prediction locked in. Weights shrink barely with alpha equals to 1.0. Now write the code, type the output in your dataset. Okay, I'm gonna grab, let's say, my Visual Studio Code out here. And since I am working with ridge regressions, I'm gonna create a brand new file, because why not? I'm gonna go here. Okay, let's go with something like RIDGE. REGRESSION. REGRESSION.py. There we go. You know what? Let's go with ridge underscore regression.py. Okay. Now, in my ridge underscore regression.py, I'm gonna go ahead and, let's say, copy my data set, because I don't want to create it myself. Okay, I'm gonna go with something like from NumPy. From NumPy, or actually, I want to go ahead and import NumPy as NP. NP is something like a universal convention that everyone uses when importing NumPy. Same with pandas as PD and polars as PL. That said, now I'm going to go with something like from Scikit-Learn linear underscore model. I want to go ahead and import ridge. Ridge is the function that I will be using. Okay, and then once we're done with that, I guess I'm going to create an X variable that is going to be equal to an array. So numpy.array array method, which is going to be having a list of lists in it. In total, how many? 1, 2, 3, 4, 5, 6, 7, 8 lists from 1 through 8. That's going to be 1. That's going to be 2. That's going to be 3. That's going to be 4. That's going to be 5. And then that's going to be 6. That's going to be 7. That's going to be 8. Oh, are you kidding me? Are you kidding me? I hate my camera. I mean, my screenshot shortcut. It keeps getting in the way, and I added periods instead of comma because I can't see my keyboard properly. There we go. Yeah, because apparently I'm touch typing and my keyboard is kept really low, so I need to like look down, like really down to see it clearly. Okay, and then I'm gonna go with something like y, where I'm gonna go with another np.array. This is gonna be for my scores. However, for my scores, I will be having a list, but not a list of lists. Instead, I'm going to be having a list of numbers. 52, 55, 61, 64. 52, 55. Oh my gosh. 52, 55, 61, 64. And then we're going to go with 70, 75, 78, 70, 75... 78. There we go. And then it's 85. All right, perfect. Once we're done with that, I'm going to go ahead and let's say add my ridge regression here. So we imported our ridge. I'm going to create a models as variable that is going to be equal to my ridge function. Now, unlike linear regressions, ridge consists of a parameter called a hyperparameter, which is going to be my alpha. And a hyperparameter is basically something that we manually set. And then I'm going to go with something like model.fit. I want to fit my x and y. Fit is basically the method that we use to train our model based on what kind of model are we training it. It automatically decides that. Okay, I guess, and then we're just going to go ahead and print stuff. Prediction is going to be equal to, let's say, my model.predict method, where I want to go ahead and predict a number, which needs to be similar to my data set here. Let's go with something like 12. Okay, and then I'm just going to go with something like print the coefficient, right? So I'm going to go ahead and print my model.coef, coef underscore. Okay, and then I'm gonna go with the y-intercept as well. Let's go with something like print my model dot intercept CEPT. Hold on, INTER CEPT. There we go. Okay, and I think that's pretty much it. Lastly, are you? Yeah, I'm gonna probably change my shortcut out of here. Like I keep whenever I'm trying to click backspace or enter, I sometimes click my shortcut for my screenshot. But that's fine. Now, lastly, I'm going to print my prediction. Okay, now let's hit Control S to save the code. I'm going to go ahead and click Control / to grab my terminal here. And then first things first, we're going to change our directory to where I'm currently at, which is my Scikit-Learn. Or you guys can see it from up here as well. 365 AI Engineering and Scikit-Learn. I'm currently in AI Engineering. I need to go to my Scikit-Learn. Scikit-Learn. Was that B? No, it's L. No! Oh god, guys, I hate getting these stupid typos. Change directory to, there we go. Okay, and then once I'm done with that, I'm gonna go ahead and run my file by going with something like py ridge ridge underscore regre regression.py. Okay, let's see. Oh, okay, I had a small typo here. I went with mode. Where did I go with mode? M-O-D-E-L. M-O-D-E-L. There we go. Okay, model, not mode. I'm gonna hit Control S again, and this time copy my py ridge underscore regression.py to run my program again. There we go. So, our coefficient is 4.58139535. Our intercept is 46, and our prediction is, let's say 102 if I were to round it, and that's like 5 if I were to round it up. Now, I'm gonna go with, let's say, an alpha of 500. Control S. We're gonna paste this here. I want to see the different variations. Oh, wow. 500 kept my weights really low. However, my intercept and my prediction went high. My coef was the only thing that went low. But if I go with 50,000, Okay, that's really, really low now. That's really low. This is 67 and that goes 68. Alright, alright. I'm gonna go ahead and copy this. We're gonna grab Claude here, paste it, and say, Sensei, I tested this out with three different alphas. With three different alpha values. Okay, which were 1, 500, and 50,000. Okay, that's it. And my coef was the only thing that kept, but actually was the thing that kept getting really low. Okay, that's it. I did not know what did the rest mean and how did I get them. Okay, let's go with something like I know that I used gradient descent to get it. However, can I get an explanation for my output? Let's go with something like for my output. And yeah, I will not be fixing my... You know what? Screw it. Screw it. We're fixing our typos. This is going to be gradient descent. That is going to be explanation. Output. Here's my code. There we go. I'm going to read the explanation after in our next 25-minute session because the time is almost up. Let's paste it and then say send it. Okay, that's it. Time ending in 5, 4, 3, 2, 1. Hands off anything that is not distracting. Moving on back to Wuthering Waves. Okay, so I was checking my events, right? Let's see my events. I wonder if I want to get her. So many people are like, I should summon for Susui, but no, it's Sui, right? But I don't know if I really want to. I was saving my asterisks for Hayuki or Zani. Or anyone better, actually. Alright, no freebies, I guess. This is one reason I need to, like, check these things out every single day. Unlock at level 17. What is this? Somnium Labyrinth? Alright. Okay, I think that's pretty much it for the events, right? I'm gonna get this right here. For the time being, I wanna see my, let's say, Convene. Pretty sure a new unit. Oh, she really did come here. I wanna kind of proceed for trial. What video card are you using? Do you mean like graphics card? You guys can get access to my specs. There we go. By typing exclamation specs on chat. That's I wonder if I should 16 days. Oh, you're kidding me. Okay, I'm saving my asterisks. I'm waiting for someone really good to come, but I could summon here, you know. I wouldn't mind getting Xiangzhen or any of the characters here. I want to get this somewhere where it doesn't get in my way. Oh god, that is massive now. There, okay, I'll just leave it there. There we go. Having it small doesn't get in my way. And why do people go with weapons? This stays... Oh! Should we go for a summon? You know what, bet. Let's go for a summon. Every 10 convenes guarantees a 4-star. You know what's good. Alright, let's see who we get. Oh, it looks like an epic character. Hold on. 3-star, not bad. Another 3-star, not bad at all. Pistol of Night. Interesting. Oh? Wait, are we not getting a character? Hey, at least I got a new weapon. I thought we were gonna get a character. Oh, Hollow Mirage. This is a 4-star. No, I thought I was gonna get a character though. You know what? Screw it. It's fine. I didn't have high hopes for this. Either way. Okay, that's it. I think that's enough wasting of time here. I don't want to waste asterisks because I'm a free to play and I want to like save as many as I can. Ever, I'm gonna claim all. 30, not bad. Okay, I think I'm gonna get back to my storyline, but why is... Oh. I'll take all the freebies that I can get. Although, why do I have a check there? Do I need to claim stuff? Okay. There we go, and then can I claim something from here as well? Yeah, I want to spend a good amount of time actually getting this thing on. Oh wow, these look kind of cool because these custom skins. Okay, I'm gonna just exit this for the time being. Let's move on to our actual quest. Okay, let's claim that first. I wanna know the quest that I'm actually gonna be doing for events, because events are limited time, right? Virtual Crisis. Water and Trials. Remaining 16 days. You know what? Let's go for this. We get 500 airstrikes for this. I want something that gives me a lot. We get 400 for that. We get 1200 for this. Hell yeah. Lament Recon. Tacit Crisis. Limited to help. Solaris. Prepare for future crisis. You know what, bet? I just see the mountain I'm in. Wow, that's far away from me. Hello, Viv Universe. It's been quite a while. Remember me? I'll go with Rover. Remember me, Rover? It's Yoren from Black Shores. Thanks for your help. Okay, our research on the combat simulator has been going smoothly, both in the Black Shores and in Riscata. There we go. The last version, Lament Recon, Solaris Soldiers was a hit with all agents. They reported that the layman simulated by Teehees felt genuinely impressive, like a real apocalypse. That feeling of pushing back against fate, clutching at the thinnest thread of hope while drowning in despair, only to finally get swallowed by the tacit discards. That's it. Time's up. Time's up. Hands off anything that is not distracting. Moving on. Back to work. Back to work. Vivek, what's your age? Sounds Tamilish to me. I'm actually 18. I'm gonna turn 19 this January 5th. Okay, I guess back to work. Let's see. Whoa. Okay, first, that's not what I asked you to test, but that's a genuinely great instinct. You went and tested Alpha 1, 500, 5000 on your own to see the pattern in action. Instead of just trusting the theory, that's a real curiosity-driven verification, and it's exactly the kind of thing that builds actual understanding instead of borrowed understanding. I want to name that before we go further. Now, let's break that down exactly what each line of output is, because you're right to flag that you don't fully know. Your code prints three things: model.cof underscore, model.intercept underscore, prediction. Let's match them to your alpha equals to 1 run. So alpha equals to 1, I got 4.5, which let's say something like 5. This is coef, the weight. Yeah. Ridge regressions are anything that decreases the weight only. 46.88, let's go with 47. This is the intercept, 101.8, let's go with 102. This is the prediction for x equals to 12. Coef, the weight, you already know this one. Confirmed your prediction at alpha equals to 1, weight is 4.58. Close to what plain linear regression would find, barely shrunk. At alpha equals to 500, it drops to 0.36. At alpha equals to 50,000, it's basically 0.004. Nearly zero. That's the penalty crushing into submission at extreme alpha. Your barely shrinks at low alpha, crushed at a huge alpha. Pattern is fully confirmed by your own data. Intercept, quick check before I explain this, since it's a term found in linear regression. Do you remember what the intercept represents, or do you want a refresher on that piece before we connect to why it changed? Can I get a refresher? There we go, and then let's send it. You should try models that drop the polite talk and talk pure code. They explain but will correct your wrongs. Example, GPT 5.0 mini. I may try that, because the reason I go with Claude's model right here, which I think it does give me a lot of explanation with the talks as well, because basically plain code is hard to just understand without any context. That's it, fair. It's been a while since linear regression. No shame in that. Okay, intercept refresher. Although, before I really go with it, I'm gonna drink some water. I'm kind of dehydrated. Hold on. Okay, so intercept refresher. Think of the line equation y equals to weight multiplied by x plus intercept. The intercept is the predicted value when x equals to 0. In your case, if someone studied 0 hours, what score does the model predict they'd get? That's the intercept. Okay? Oh, I see. Wait, the intercept is the predicted value when x equals to 0. In your case, if someone studied 0 hours, what score does the model predict they'd get? That's the intercept. It's the starting point of the line. Oh, okay. Where it crosses the y-axis before the weight even starts multiplying anything. Now, here's the connection to what you're seeing. Notice your intercept is changing across your 3 runs to 46.88, 65.86, 67.48, given that the weight is getting crushed towards 0 alpha increase, meaning our studied is having less and less effect on the prediction. What do you think the intercept is doing to compensate? Any guess? Any guess as to why it would climb towards the high 60s? Let's see. So now here's the connection to what you're seeing. Notice the intercept is changing across your 3 runs to 46, 65, 67. It keeps increasing. Given that the weight is getting crushed towards 0, the alpha increases. As the alpha increases, meaning our study has less and less effect on the prediction, what do you think the intercept is doing? Okay, wait, let me say, I don't know. Okay, because I did work with intercept when I was working with linear regressions. Let's say don't know. Although I probably need a better example. What the hell? There we go. And let's just fix my as well. I don't think is a real word that we use, but it's fine. Okay, no worries. That's a real I don't know, blah, blah, blah. Look at your actual data. So these are my scores for my data. So 52, 55, 61, 64, 70, 75, 78, 85. The average of those scores is roughly 67.5. Now, think about what happens as alpha gets huge and the weights gets crushed towards 0. Your formula, y equals to weight multiplied by x plus intercept basically becomes y equals to basically 0 multiplied by x plus intercept. Y equals to intercept. If the weight can't do its job anymore, can't respond to our studied, the models only move left to minimize. The models only move left to minimize error is to predict roughly the same number every time, and the smartest same number every time guesses the average of your actual scores because that minimizes error when you're not allowed to vary your answers. That's exactly why your intercept climbed to 67 at alpha equals to 50. That's almost exactly the average of your y values. Oh, I see. The model gave up on using our studied as useful information and just retreated to guess the average since I can't afford to trust any single feature anymore. Okay, that makes sense because to decrease the amount of errors when we use ridge regressions with gradient descent, it's, let's say, limits the weights from going really, really high, and the higher the weights go, the less errors we really have, but the higher the weights go, the model gets overconfident as well. Therefore, we try to limit the weight, but limiting the weight a lot with, let's say, 50,000, setting our alpha to 50,000, would basically mean that, it would basically mean that our weight, our hour study, there we go, our dataset values are not reliable anymore. I see. I should have said that to Cloud, damn it. Okay, good, that's the real important intuition, blah, blah, blah. Now let's close the loop with prediction, the last piece. So I did prediction equals to model predict a list of 12. You asked it to predict the score for someone who studied 12 hours. Let's check this against your own alpha equals to 1 output. Go f underscore equals to 4.58, intercept equals to 46.88, prediction equals to 101.86. that's just the formula plugging in real numbers. Y equals to weight multiplied by x plus intercept. Y equals to 4.58 multiplied by 12 plus 4.6.88. Y equals to 54.96 plus 46.88. Okay, we're basically solving a math here. So it's weight multiplied by our data set plus our intercept. Intercept is 46.88. Y equals to 101, matches your tiny rounding, okay. Quick check on your end using alpha. Using your alpha 5000 coef underscore equals to 0.004, intercept equals 67.48. Can you predict what the output for x equals to 12 should roughly be before I confirm it against what you actually got? 67.53. Alright, I guess we're gonna have to bring out the calculator for that stuff. Using your alpha, so using my alpha of 50,000. What value did 50,000 actually get me? Hold on, let's grab my Visual Studio here real quick. So 50,000 grabbed me 67.52. 67.48. Wait, this is the math for our alpha. Can you predict what the output for x equals to 12 should roughly be before I confirm it? The output for x equals to 12 should be. Okay, my predictions are here. So it's 67.52, but why did we get 67.52? Okay, wait, that's the coefficient, that's the intercept. What is the formula? What is the formula? Let's say to predict it, question mark. Interesting. What was the formula to predict it? Okay, same one you've had the whole time, just phrased differently. It's the linear regression equation you already used. Okay, so weight multiplied by x plus intercept. So our weight is going to be 4.58. Okay, let's go with something like 4.58 multiplied by x, which is going to be 12. Multiplied by just my intercept. No, not multiplied. Plus my intercept. Oh, are you kidding me? Oh, there we go. Okay, I can just change the plus. My intercept is 67.48. 67.48. 122.44. Hold on, I'm going to take a quick little picture of this. Okay, this is what I got. Why was there a triangle beside my picture? Hold on, let's back up because I think a wire got crossed on which numbers to plug in. You need to use 4.58 multiplied by 12 equals to 54.96. But that's your alpha equals to 1 weight, not alpha equals to 5,000 weight. Let's redo it with the right weights this time. Weight is 0. Hold on, wait. There we go. So that is my weight. Okay, I'm gonna grab my calculator back up here. So it was basically weight multiplied by our data, right? So my weight is going to be 0.003 93669 93669 multiplied by 12 plus our y-intercept, which is going to be our 67.48. 67.48. Okay, so our weight is... Oh, I see. There we go. Okay, I think I understand the math too now. Oh, I see. I think that I understand the math as well now. In order to make a prediction, prediction, we need to multiply our weight by our data. Let's go with something like by our data that we need a prediction for. and then we add it with our, let's say, intercept. Okay, perfect, and then let's just go ahead and send it. Okay, it was not as complex, to be honest. Exactly right, and look at that, 67.527 matches your real terminal output if 67.529, yada yada. Almost exactly, tiny rounding in the calculator versus the model's is more precise internal number. Your math confirms your own. Codes for output, that's not telling me. That's not telling me. That's not me telling you it's right, it's you verified it, there we go. Okay, and you nailed the general rule too. Prediction equals to weight multiplied by input plus intercept. That formula doesn't change whether it's linear regression or ridge regression. Ridge only changes how the weights gets found during training, via the penalty, not how predictions get made afterwards. So let's zoom out and look at what you just built end to end with your real numbers as proof. Alpha 1, 500, yada yada. And basically my outputs. That's the entire ridge story visible in one table of your own real output as alpha climbs the model trust hours studied less and less and treats towards just predict the average and its safety net. That's a strong stopping point. I want to keep going. You went from theory, yada yada. Okay. It has just been an hour since we started. Let's go with something like, therefore. Hold up, there we go. Therefore, I can keep going. That said, let's go with... Oh god, are you kidding me? Okay. That said, what is the next category that we will be working on? Let's go with something like working on. And how many subcategories does that category have? I'm pretty sure that we will be working with, I think, classifiers, right? Hold on, let me grab my roadmap here. Yeah, classification. No, we're done with that. Oh yeah, classifications is SVMS. This is what we really needed to work on. And then we're gonna work on clustering and dimensionality reduction. For now, it's classifications. Okay, confirmed against the roadmap. Here's what we're doing. Ridge regression is basically done. You've got the theory and real concepts slash output tested across the three alpha values. Right after ridge on the roadmap comes SVMS, support vector machines, which closes out the classification subsection. To answer your actual question, the category structure for classic machine learning with Scikit-Learn has 4 subcategories. Alright, wait a minute. Okay, let's read. Ridge regression is basically done. You've got the theory, blah blah blah. Okay, to answer your actual question, the category structure of classic machine learning with Scikit-Learn has 4 subcategories: regressions, classifications, clustering, and dimensionality. Classification, there is decision trees, random forest, SVMs, decision trees, random, okay. So, SVM is next, and it finishes off classifications entirely. After that, clustering, then PCA, then model evaluation, then Project 2. In case you guys did not know what Project 2 is, or that you guys are actually kind of new here, basically at the end of every phase in my roadmap, I work on a mini project that consists of all the prerequisites that I did work on or learn under my current phase, which in this case is math and machine learning. And yeah, I was done with my phase 1, which was the bedrock, and I did build a fully automated web scraper. You guys can get access to the code and everything in my GitHub. That's it. I'm just gonna hydrate my lips real quick. Hold on. I'm gonna just copy that because I think I need to move on to a new chat. I think I'm gonna lose a lot of tokens if I keep using or keep reusing this chat. Hold on a damn minute. Just paste that, send it. Okay, perfect. I think there we go. Okay, I'm gonna drink some water real quick. Hold on. Alright, I guess let me just get my new chat out here and say something like, Same live exclamation. Alright, and then I'm just gonna go ahead and grab this in the other window. Because I wouldn't really use that now. Okay, we're live. Bridge regressions is done. You wrote real code, tested 3 different plans, tested 3 different alphas yourself, and connected the dots on Y. High alpha pushes the model down, predicting the average, okay? That wasn't handed to you, you reasoned it out. That's the standard I expect every session. Today we're stepping into SVMs, support vector machines. This is the last piece of classifications before we move on to clustering. Brand new model, brand new way of thinking about the problem. Hold on. There we go. Brand new way of thinking about the problem. This is not a small patch on something you already know, like Rich was on linear regressions. Treat it as a fresh territory before I teach a single thing. Straight question, no shortcuts. Do you already know about SVMs, even if it's just the name and nothing else? Tell me exactly. I have never worked with it. And that I do not know anything about it. Okay, and then I guess I'm just gonna go ahead and send it in. Good, honest answer, no faking it. That's exactly what I want to hear. Zero foundations means we build this right from the ground up, no gaps. Let's start with the core idea before any code touches the screen. The problem SVM solves. Support vector machines. Force logistic regressions and decision trees. Forget logistic regressions and decision trees for a second. Imagine you have a group of points on a graph, say red dots and blue dots, and you want to draw a line that separates them. Here's the thing. There are usually many possible lines that could separate red from blue, not just one. So the question that SVM asks is different from what logistic regression asks. Logistic regression asks what's the probability this point is red or blue. SVM asks something much more stubborn. Out of all the possible lines that separates these groups, which one line gives the most breathing room on both sides? That breathing room, the distance between the separating line and the closest from each group and the closest points from each group is called the margin. SVM's entire goal is to find the line that makes this margin as wide as possible. Why does this matter if your separating line barely squeezes something between 2 groups with no room to separate a brand new data point that's slightly different from what you trained on? Could easily land on the wrong side, but if the line has maximum breathing room on both sides, new points are far more likely to land correctly. Wide margin equals to more confidence the more confidence the model will generalize to new data hasn't seen. Wait, gut check before I go any further. Do you think this? Don't overthink this, just tell me in your own words. Why would a line with a wide margin be better than a line that barely squeezes between 2 groups? Let's say something like, do not know. Ken? I don't know, can I get a better, a better real world example, question mark? I did not understand this explanation. Okay, and then I guess let's just go ahead and send it. I forgot to end that with a period. But I'm gonna drink some more water because I'm getting too dehydrated here. Okay, fair, you're not going to fake it, blah blah blah. Okay, real world example. A bouncer with rules. You can run a club. You run a club, you need a rule for your bouncer to decide. Let someone in or turn them away. Say the rule is based on age. You know people who caused trouble before were all under 21? People who never caused trouble were all 25 and older. Wait a minute. A bouncer with a rule. You run a club, you need a rule for your bouncer to decide. Let someone in or turn them away. Oh, I see, I see. Okay, say the rule is based on age. You know, people who caused trouble before were all under 21. People who never caused trouble were all 25 and older. You need to pick one number, a cutoff age, and tell your bouncer, anyone below this number, turn away. Now, here's the actual decision you're facing. You could set the cutoff at 21 right after the edge of the troublemakers. You could set the cutoff at 23, smack in the middle of the gap between 21 and 25. You could set the cutoff at 24.9 right at the edge of the safe group. All three of these cutoffs technically separate your your two groups perfectly using your past data, zero mistakes on the data you already have. But think about the next person who walks up. Someone new, age 21.5, age 22, age 24. Which cutoff, 21, 23, or 24.9, would you trust most to make the right call on someone brand new who wasn't in your original data? Let's say, just to be safe, I would go with the lower number of 21. Let's say something like, because people at that, let's say, age range were the ones that caused trouble. And again, this is just a guess. This was just a prediction. No understanding whatsoever. There we go. I mean, it's not like I did not understand at all, but it was mostly a prediction. Good, you gave me a real answer instead of freezing up, and you were honest that it was a guess. Alright guys, that's it. That's time. Hands off anything that is not distracting. Moving on to Wuthering Waves. I was under a quest, right? Which was going to give me 1,400 airstrikes. Okay, the last version, Lament Recon. Solier Soldier was a hit with all the agents. They reported that to the layman simulated by Dead Sea felt genuinely immersive, like a real apocalypse. That feeling of pushing back against fate, clutching the thinnest threads of hope, while drowning in despair, only to finally get swallowed by the tacit Discord outbreak in the end. It left everyone in an awe. Sounds like something Christoforo would be into. Oh, you mean the overseer of the Fraxidius? Is that a compliment or are you being sarcastic? Well, I was just repeating everyone's feedback as it was, although, I do admit I added just a tiny bit of artistic expression to it. Just a tiny bit. Wait, we're gonna go for this quest, right? Never mind the details, I was only joking. Now, on to our business. I've collected some feedback from the agents and researchers and made some improvements to the simulator based on it. I might need your help testing it out again. I'll fill you in the specific updates once we meet. I'll see you at the Star Torch Academy, rover. Alright, so I guess we're moving on to the Star Torch Academy. Oh, everyone has a message. Okay, I'm not really.
I never thought there'd come a day where I'd be congratulating you on your graduation as the teacher. Happy graduation, mentor. I'm so glad I get to witness this moment. It's just... this is the second time I'm seeing you off from Lahairoi.
Voice messages are the thing, I don't need to read it out. I'm sorry you've forgotten your past time together.
I'm sorry I've forgotten our past time together.
Don't be. I know you had your reasons, and I don't feel disappointed. But last time you left, you said that Lahairoi will continue forward on its own feet. I've carried those words with me ever since. So this time, may I be the one to offer a proper farewell.
Okay, I want to listen to Hayuki's, to be honest. She's my favorite character. Oh, wow.
Is there something you wish to speak of privately?
Okay, I'm not gonna waste more time in that. That's such a waste of time. I can listen to that later on, but I want to go for this. Okay. Alright, I guess let's just go ahead and go. Do you want to fast travel? Alright. So apparently we're gonna go ahead and fast travel to the new location. I think this is not, this is like far from the actual storyline, but I think that it should be pretty good. Because I'm gonna be getting Asterix here, and it is a limited event. Yo, Hiren. I don't know if I want to do this though. Okay, oh, you're here. Okay, you know what? Even from the intel I saw, I still couldn't tell you from the pictures just how massive Star Charge Academy is. All these students here look incredibly energetic as well. Like they could pull a 10 all-nighters in a row on their research and still be fine. And look at me, a couple of sleepless nights and I'm already checking the drain for hair loss. To be young again. Oh, sorry, I got sidetracked. Just as I mentioned, over wave lines, we've made adjustments to the previous Lamage Recon. Salvia soldiers. I mean, okay, you know what? I'm just gonna read this. I'm gonna go back to our main storyline. This is kind of boring. Okay, long story short, this new simulator works much the same as the last one. Both use panoramic holographic technology to recreate scenarios where various locations are hit by critical crisis, and much more. Basically, it's about dealing with tacit discord outbreaks, and I'm sure it's nothing new to you at this point. Layman Recon, a Salvia soldier learned heavily on strong resonators and their resonance abilities as the deciding factor in combat. But that doesn't apply to all agents. Some agents are better at working with their environments, using whatever items and tools they can find to deal with tacit discords, rather than just relying on their resonance ability. Just like that famous action. Okay, wait, hold on. I'll read this and then we'll call it a day. That's time though. Just like that famous action movie star from Huanglong did in those old movies. Who class collected. Okay, that's it. Let's get back to work. That was the worst. That was the worst use of my break time. What the genuine hell was that? I wish I followed the regular story. The regular story has voiceovers, nice acting, and all that things. Okay, that's it. That's it. Good, you gave me a real answer instead of freezing up, and you were honest that it was a guess. That's exactly the right move. Now, let's check against the logic. Here's the problem with picking 21. Your troublemakers were under 21, so the actual last troublemaker age you saw might have been like 20. What game is it? It's Wuthering Waves, or you could like download it with WUWA as well, WUWA. Or the entire spelling is WUTHERING and then WAVES. It does take a lot of storage though, but it's really good. Okay, your troublemakers were under 21, so the actual last troublemaker age you saw might have been like 20. If you set your cutoff at 21, you have almost zero room for error. Someone who's 21.2 years old, barely older than your worst troublemaker, gets let in immediately. The tiny miscalculation, one slightly off data point, and your bouncer is letting a troublemaker walk right in. Same problem in reverse. If you pick 24.9, you're hugging the safe group's edge. No room for error either. No room for error there either. 23, the number smack in the middle of the gap, is the safest cutoff. Why? Because it has the most buffer space on both sides. A new person who's 21.5 still gets rejected correctly. A new person who's 24.5 still gets let incorrectly. You're not gambling on borderline classes you built in a cushion. That buffer, the gap between your cutoff and the closest person on each side, is the margin. SVM does not just find a number that separates your groups, it specifically hunts for the cutoff that gives you the maximum buffer on both sides. It's like picking 23 instead of 21 or 24.9. The people sitting closest to that cutoff, your oldest troublemaker and your youngest safe person are the ones that actually determine whether the line goes. Everyone else is basically irrelevant to the decision in SVM. Those closest points to have a specific name support vectors. That's literally where support vector machine gets its name. The machine is just built entirely around that support or define the margin. Quick check in your own words. Why does SVM care so much about the points closest to the boundary and basically ignore everything else? Like the troublemakers who was 12 or the safest person who was 40. Because it tries to avoid errors, question mark? Okay, and I also see why we went with 23. When I picked 21, let's go with something like when I picked 21, I thought that no one under or equal to the age of 21 will be accepted. However, I was wrong. And let me fix my typo real quick. Pickles. There we go. Okay, when I picked 21. However, I was wrong. Only people above 21 would get picked. And anything below that would be rejected. Okay, I see. And then I'm just gonna go ahead and send it. Hold on, let's sharpen two things you just said, because one is a real insight and one is a small misread I need to correct before it sticks. First, the good part, you caught yourself questioning your own reasoning about 21 cutoffs. That's the self-correction instinct working. Good, and now the correction. Nothing was wrong about 21 gets in 20. Nothing was wrong about 21 gets in, 21 and below gets rejected. That's just how a cutoff/threshold works either way. Whether it's set at 21 or 23, that part was never the issue. The issue was never which side of the number people fall on. It was how much safety cushion the number itself has. 23 isn't better because it challenges who's above/below. It's better because it's sitting in the middle of the gap instead of hugging the edge. Now the part I actually asked you and you didn't quite answer. Why does SVM care about the closest point, your oldest troublemaker, your youngest safe person, and basically ignore the far points, H12, yada yada? Here's a nudge to get you there. Think about what happens if you delete the 12-year-old troublemaker from your data. Does your cutoff of 23 move at all? Now think about what happens if you delete the 20-year-old troublemaker. The one closest to the boundary instead. Does 23 still make sense? I believe, let's say, I did not understand the concept of SVMs. Therefore, it is hard to answer. I guess let's get a better explanation. Hold on, I'm gonna drink some water real quick. Kinda dehydrated. Okay, that's a real sign, not a cop-out. You're telling me the foundation isn't solid enough to reason from yet, not that you're avoiding the work. Okay. Forget far and close as vague words. Let's use real ages. Troublemakers, bad groups. Ages 15, 18, 20. Safe group, good group. Ages 25, 30, 40. The cutoff has to sit somewhere in the gap between 20 and 25. That's the only open space between your two groups. Middle of that gap, 22.5. That's your cutoff. Now, does it matter to that one troublemaker? Now, does it matter that one troublemaker was 15? To find the middle of the gap, all you need is what's the highest troublemaker age? 20. And what's the lowest safest age? 25. Oh, then you split the difference. Excuse me. 20 plus 25 divided by 2 equals to 22.5. Oh, okay, now I see. Then 15-year-old never entered that math at all. Whether that troublemaker was 15 or 10 or 2, it doesn't change 20. And 20 is the only troublemaker age that actually matters for finding the middle of the age gap. Try it yourself now with real numbers, no vague words. If I told you the safest group was actually 25, 30, 40, and 90 instead, does the cutoff from 22.5 change at all? Walk me through why. Or why not, using the same highest and lowest logic I just used? It would not change the cutoff at all, because the highest troublemaker age is still 20, and the lowest safe age is 25. Therefore, the middle ground, oh god, there we go, GROUND, ground is, let's say something like 20 plus 25. This goes in both parentheses because we want to do the math first. Divided by, let's say, 2. Okay, if you find the average, that's it. You just did the actual math SVM does. And you did it yourself. The 9-year-old could show up in your data, could vanish from your data, doesn't matter at all. It's dead weight to the calculation. The only two numbers that actually determine whether your cutoff goals are 20 and 25, the closest point from each group. Now you've got the real definition of the vague one. Support vectors equals the specific data point. The specific data points closest to the boundary. The only point that actually determine where the line cuts off. Every other point in your data set could disappear tomorrow and the model wouldn't move an inch as long as the support vectors stay put. That's why it's called a support vector machine. Every other points in your dataset could disappear tomorrow and the model wouldn't move an inch as long as the support vector stays put. I see, the whole model is built and supported by just those critical few points, not the full dataset. Hold on, support vectors equals the specific data points closest to the boundary. The only point that actually determine where the line slash cutoff goes. Okay. Quick recap of what you actually know in plain terms. SVM finds the boundary with the widest margin buffer between two groups, not just any boundary that separates them. That margin is measured from the closest point on each side. Those closest points equal support vectors, and they're the only points that matter for defining the boundary. Far away points contribute nothing to where the line ends up. Okay, one more check before we go anywhere near code. This is important, don't rush it. If your bouncer example, in your bouncer example, what were these support vectors? Given me the actual age. Give me the actual ages. 20 and 25. They were basically the only thing. Correctly, no hesitation, no hedge. You've now got the real foundation. SVM equals to find the widest margin boundary between two groups. Margin equals to measured from the closest points on each side. Those closest points equals to support vectors, in your example 20 and 25. Everything else in the dataset is irrelevant to where the boundary sits. That's not a surface level definition anymore. You built it from real example, got confused, asked for something different when it wasn't landing, and then did the actual arithmetic yourself. That's the whole point. Now, one thing to flag before we move to code. Everything we just did assumed your two groups are cleanly separable. There's an actual gap between them, like 20 and 25 never overlapping. Real data is rarely that clean. SVM has a way to handle messier overlapping data too, but that's a later layer. Okay, don't worry about it yet. Right now, the immediate next step is seeing this in actual Python syntax. Quick question before I show you anything. Have you ever seen SVC or from Scikit-Learn.svm import SVC anywhere? I have not. Now, while Claude is really answering my question there, I'm gonna go, or let's say saying something, I'm gonna drink some water. Okay, so the class we need is Scikit-Learn. So from my Scikit-Learn.svm this time, I gotta import SVC. SVC stands for Support Vector Classifier, the classification version of SVM. There's also SVR for regression, but we're not there yet. Basic setup, same shape as every model you've used so far. From Scikit-Learn.svm, import SVC, model equals to SVC, model.fit x and y. Okay, fit is so generic, I've at this point completely memorized that I need to always use fit here. Fit is what we use to train our model. Predictions equals to model.predict x test. Look familiar? It should. It does actually. Everything is literally the same. Fit and predict are the same pattern as linear regression, logistic regression, decision trees, random forest, and ridge regressions. Scikit-Learn keeps that interface consistent on purpose. The new stuff is what's happening conceptually inside SVC, not the syntax shape around. One parameter you need to know about right now is kernel. Okay, is kernel a hyperparameter or is it like a regular one? For today, okay, you know what? Hold on, I've been drinking way too much water. I'm gonna use the restroom real quick. Give me a quick little second and I'll be right back. Already mic testing. Okay, perfect. Let me go to my gameplay screen again. There we go. Okay, I'm back. Let's see. So, we were reading about the kernel regressions, right? Okay, so one parameter you need to know about right now is kernel. Model equals to SVC. Support vector SVC. Support vector classifier. There we go. Okay, kernel equals to linear. For today, we're using kernel equals linear. This means SVM, server vector machine, draws a straight line boundary. Exactly like the bouncer H cutoff example we just did. There are other kernel types that can blend the boundary into curves for messier data, but that's a later layer. Don't touch it yet before we write anything. Quick prediction, grounded in what we just built. If you called model.support_vector_ after fitting this model On a data similar to your bouncer example, what do you think it would return? This is a guess because I am not familiar, let's say something like with the syntaxes. However, I believe that we will get 23.5. There we go, the middle ground. And then I will fix my typo with familiar. And then let's just go ahead and send it. Okay, good guess attempt, but let's catch this now before it calcifies. You mixed up two different things, and it's an easy mix to make. A 23.5 or 22.5 in numbers is the cutoff. The boundary itself, that's not the support underscore vector underscore returns. That is not what this thing returns. Support underscore vector underscore returns the actual data points that define the boundary. Okay, how in the genuine world would I have known that? The raw ages themselves, not the middle point between them. Go back to your own example. The support vector were 20 and 25. The support vectors were 20 and 25. Those specific ages, the actual troublemaker and the actual safe person sitting closest to the gap, the boundary 22.5 is something SVM's actually SVM calculates from those two support vectors. Oh, wait, never mind. I think I should have known this because basically 20 and 25 are the support vectors, and it was probably self-explanatory that support underscore vectors really gives me the support vectors. Gives you the ingredients, not the results. So model.support underscore vector underscore would return something like 2025, the actual data points, not the middle point between them. Quick check, no new material, just locking this in. In one sentence, what's the difference between what support underscore vector underscore gives you and what the actual decision boundary is? Oh, I see. The support underscore vector, oh god, there we go. The support underscore vector underscore gives me the supporting values. However, the actual decision boundary is the margin slash middle ground slash cutoff. Alright, and then let's send it. I did add a slash there. Exactly right, support vectors equal to the raw data points that supports the boundaries. Decision boundary equals to the calculated cutoff derived from those points. Two different things, and you just nailed the distinction cleanly. Now you've got everything you need to write real code. Time to get your hands on the keyboard. Same rules as always. You write it, you run it, you send it. You send me the real output. Okay. Your task, create a small data set. Two groups, similar to bouncer example. Use hours studied versus pass/fail or any numeric feature you want. Your call, just make it clearly separable, a real gap between the two groups, no overlap, since that's the only case we've covered so far. Import SVC, okay, create the model with kernel equals to linear. Fill it in our data, print model.support. Okay, before you write a single predict, given the data set you're about to design, you already know what values you're putting in. What do you expect support underscore vendors to print out? Support underscore vectors underscore is going to, let's say, give me the, what was the example? The data points, the raw data points, which is 20 and 25. However, before I write the code, can you explain me what kernel equals to linear means? I mean, I did get an explanation, but apparently I forgot because the explanation was kind of vague. Good question to ask before writing code. But first, quick catch on your prediction. 20 and 25 were the numbers from the bouncer age example. You're about to build your own data set with hours-studied, or whatever you pick, so your actual support vectors will be whatever your closest data points ends up being. Not literally 20 and 25 again, the concept you said is right. Support underscore vectors underscore equal to the raw closest data points. Don't just lock in these specific numbers until you have built your data. Alright. Now, what kernel equals to linear means. Remember the bouncer example? I do. We drew a straight line cut off between troublemakers and safe people. One number, the clean split. We drew a straight line cut off between troublemakers and safe people. Yeah, we did. Kernel equals to linear tells SVM, support vector machine. Only draw a straight line boundary, don't get fancy. That's it, that's the whole concept for today. It's SVM saying, assume a straight line can cleanly separate my two groups like your bouncer cutoff did. Why would the word kernel even matter? What's the alternative? Real world data isn't always cleanly split by a straight line. Sometimes your two groups are tangled up in a way where no straight line can separate them. Picture one group surrounded on all sides by other, like a bullseye. In cases that SVM can use different kernels, RBF, poly, etc. If I'm not wrong, poly means multiple, more than two or more. I think it was 3 or more. That bend the boundary into a curve instead of a straight line. We are not touching those today. Oh, okay. We're basically just working with kernels, right? So let's go ahead and grab our Visual Studio out, sure. And I'm gonna go ahead and use Claude as a reference. Okay, because I did not know these syntaxes. I mean, I sort of do, but then I still need to fact check some of these syntaxes. That's time. Hands off anything that is not distracting. Moving on back to Wuthering Waves. Okay, I think I've heard of it. I wanna just leave this. Can I leave it? Because I don't want to do the event. That's a waste of time. I wanna complete my actual storyline. Head to Jinzhou. Wait. I'm lost. Oh, I'm lost. How do I get back to my actual quest? Wait a minute. I got the time right now, but I wanna get back to my literal storyline. Quest, there we go. Okay, I think this is my actual quest. So I wanna go with something like go. Oh, we can teleport? Hell yeah. Do you want to fast travel? Alright. Okay, I'm gonna bring some water. There we go. Okay, so apparently we gotta enter the city hall and find the grand library. Grand library route map. Top left corner of the map carries a highlight mark. This may indicate the location of the puzzle. Okay, tap anywhere to close. I see. Okay, so enter the grand library done. Inspect the map done. Move to the vases to correct the positions. Where is the vase? Here? No? Okay. I think I need to... Okay, I wanted to, like, show me, like, can I hit tab or something for it to literally... Okay, I don't know what I did, but apparently I did so. Wait, I think I was in the place, right? Here? I am in the place. To correct the position. There we go. So apparently we need to go there, but then it disappears. Oh, there we go. These. Move the vase. I think I've heard a low grumbling noise. Oh. Alright. Enter the grand library via the hidden entrance. Oh. Solo Challenge Grand Library Jinzhou is a home to one of Hualing's unique database centers. Managed by the Sentinel and controlled by the Jinzhou Magistrate, it uses time as an index and precisely records information related to the city's establishment, making it a comprehensive and objective resource. The class books of Jinzhou, stored in City Hall, hold important data collected since ancient times. This vast database holds answers to any questions one may have about Twaling's history. Oh, character level that recommended is 24. I'm out of here. I'm just kidding. I'm not specifically gonna be out of here because
Why
I
hesitate if you know what you want?
I can upgrade my character.
Let's reach farther destinations.
I will be there for everyone as we head
Everyone is
toward our.
weak.
Eyes on the horizon.
Eyes
I
on
should
the
try to smile
horizon.
more, you say?
I should
Like
try to smile
this?
more, you say? Like this? Okay, who is my best characters here? For a fact, I know Rebecca is my best. Okay, we just got a new pose. I want to try to upgrade her somehow. I cannot... Oh, wait, I can upgrade her? Wait, hold on a damn minute. This is training pistol. Wait, why do I want to upgrade our training pistol? Oh, is that why we use our pistol? You know what's great? I'm upgrading her as... However many times does it take? Alright, and then I want to go with... Experience reached. Okay. I guess that's pretty much it. Is she stronger than before now? I can upgrade her even more? Okay, can I... Did I upgrade her or something? Oh, 40. Wait, I think that's to make her weapon stronger. Enhanced. There we go. So... I can't... Oh, I had to ascend her. I don't have the items to ascend her. Next ascension at SOL3 phase. Okay, so she's 40.
Perfect
She's-
weather for a walk today.
Perfect weather for a walk today. Oof.
Maybe not.
Okay. There we go. I'm gonna upgrade all my characters, to be honest. Because level 40, if it's recommended, I best be level 40. 30, 31, 37, 38, 39, 40. Even though I have like a lot of resources which I did not use. Alright. Okay, next up I'm gonna go with my final character. I don't know if I should go with her, Yang Yang, or... Okay, she's good, but I don't know if she's Rebecca good. I'll just keep her. I'll just keep her, to be honest. Can I ascend? Oh, I can level her up. Oh. If I can, why not? Oh god. I'm gonna go broke after this. I was saving my resources for a good character though, but it's fine. I'll grind again. I didn't waste any ass strikes or anything, so that's good. Okay, at least she's a 4-star. I'm gonna send her too, because I want to be ready for when I go to the dungeon. I can't be weak. There we go. I think we're as ready as we get. Okay, I guess now let's go ahead and enter the dungeon. All my characters are level 4. Wow. 5,000 HP. Alright. Let's start our challenge. Let me know if you guys think that I need to have some better characters on. I will be keeping this somewhere that doesn't get in the way.
The database.
I must have the stuff. Open the gates. Head to the... Oh?
Part of the building is submerged. I should be able to find the hidden path underwater. It seems I have a puzzle to solve. Guess I'll check on the mechanism in the middle first.
Alright. Investigate the symbol, or what was that thing? Gather 5 tones to align in tune. The bell shall guide your path. Find key notes to determine tone. To achieve shall be unmasked. The archive shall
I
be
see.
unmasked. Being a freaking
The
poet
control
out there.
panel here does look like a musical instrument, but 5 music notes seem to be missing.
Sounds like Rover. Oh, he is Rover.
So to gain access to the database, I will need to recover the 5 missing notes stored on those sonodiscs. What is that sound coming from behind the Symphodi?
Symphodite. Select sonodisc.
This must be one of the missing notes. Now, how do I connect it with the Symphodi?
So we place it here. Alright. Oh, we need more. We need like
Part of
6
the
of
score
them.
holder just lit up, as I expected. The
5 of
drum
them.
over there seems to have unlocked.
Okay, so activate.
The bell just raised out of the water. So that's what it meant by having the bells guide my path.
Oh, I see. Okay, so strike the bell and adjust it to the correction. Wait, what do I do? Let's go with Rebecca. Oh, there we go.
A new walkway has shown up. I must have solved the first puzzle. Seems I will need to look for more sonodiscs in there.
Okay, so arrive at the new room.
Come on!
Tacit discords? Inside the city hall. No, they're not real. They must be some kind of digital simulation. It seems they are the guards here. Interesting how I'm not hearing sirens, despite having destroyed every one of them.
Hey, Rebecca was a freaking
Apart from the
overkill.
simulated tacit discords, it's unusually quiet in this place.
Investigate. Multiply 54 with 4/3 of the frequency you seek. Find this node in the west, while the prophet is beyond reach.
I suppose it's telling me where I can find the next sonodisc. I think it mentioned a direction. What does that last sentence mean, though? That sound. It's coming from the west.
Interesting. So we apparently go to the right. Big sonodisc. Oh, another
This
one.
is the second sonodisc. I should bring it to the Symphodi.
Alright, on my way.
Here we go.
There we go. Reconnect. Okay, that's our second sonodisc. 3 more to go. Wait, is the water getting lower or are we getting higher? We're going higher?
The water level just dropped again. There's another 2
okay.
drums. One in the east, and another in the west. I
One
may
in the
find more
east.
sonodiscs down there.
Where do I go? That's 28. Okay. Oh, so it's lower. There we go. Activate. Alright, we get another
So
one.
this is the right way to go. I am being
was like a-
fed just enough information to work out the puzzle. This does look like Miss Magistrate's doing.
How do I... I'm stuck. Oh, there we go. Rebecca is the one for this. Even her. Am I doing something wrong? It's so hard to fight with this. Oh, there we go. We need to break it. It probably has an HP or something. Take the elevator to reach upper levels. Alright. I want to use her as my tank, but then her HP is lower than my freaking
The music I just heard. It must be the sonodisc.
her HP is lower than my other character. Head to where the sound comes from.
Here it is. Time to deal with the guards. Jinjo
Oh.
City Hall is the
I
political
want to
hub.
show you guys my
While the
shield.
Grand
It
Library
won't
holds
deal
vital
much damage
data.
to me at all.
Considering how I just took out all those guards,
Yeah,
this
some amount of
place is
time.
oddly underprotected. If my guess is correct, the magistrate may have retrieved the third sono disc. Time to head back.
Alright, so we go back here. Right? I'm lost. Are we gonna go here? Where do we go? Oh, there we go. I have to open the door. There we go. Okay. Activate. Okay, so we gotta go
Another
ahead and
platform.
connect.
Bells
Another
will lead my
platform.
path. Huh. I'll go work out the passageways.
Alright. So strike the bell to adjust the orientation.
Time to go big!
Time to go big. Oh no! Bro, why did I go with Rebecca? She's so flashy.
Wind in my aid.
And in my
I will
aid,
protect.
I will protect
Counting on you.
you.
Steady there.
Am I doing something wrong? Oh, investigate the room. Maybe we're done with this. What the hell?
Let's take it slow.
This feeling. I'm being watched. Must
our
be another
final.
sono disc. This is the
There we
fourth
go.
missing note.
Open.
Almost there.
Now I know how to go with this. We just basically, right? What? How do I get up there? Oh,
Everyone stand down.
I activate. Okay, that's it. That's time. Hands off anything that is distracting. Moving on, back to work. There we go. Let's just go ahead and grab my timer up here. Oh god, I really wanted to connect that sono disc. That said, I was about to write my code in Visual Studio, right? There we go. But first things first, before I really write my program, I'm gonna go to Scikit-Learn and let's go ahead and let's say create a file for my SVMs. I'm gonna go with something like svm.py, right? That name sounds a bit correct, I guess. Okay, so for my svm.py, I'm gonna go ahead and import something from my sklearn. I'm gonna import svm, or was it sv? Okay, it was svm. Support vector machine. From my sklearn.svm, I want to go ahead and import svc. Interesting. Okay, and then once I'm done with this, I'm gonna go ahead and create a data set. So I'm gonna go with something like x that is gonna be equal to, I'm assuming it's gonna be a list of lists, where I'm gonna have 9, and then we're gonna go with something like 12, and then we're gonna go with something like 18 and 21. Okay, those are all the data for now. As opposed to, I don't know, this is gonna be 25, and then we're gonna go with something like 30, 40, a list of 40 and 90. I do not know if my data set is kind of accurate here. I may need to fact check this part, but I'll do that in a bit. Okay, and then once I'm done with this, we're gonna go ahead and create y as well, which is prediction. I'm gonna add pass as a placeholder here for now because I don't know what to do with this. And then we're gonna go ahead and create a models as variable that is going to be equal to our svc, which basically means support vector classifier, which is going to be requiring a parameter of what was the name? I forgot. I was asking a question about it. Oh god. Kernel, there we go. Kernel is going to be equal to linear. All right, and then we're going to go with something like model.theFit method, which is going to be in charge of training my model. I'm going to give it my X and Y parameter. I don't know. Okay, and then we're just going to go with prediction. Prediction, that is going to be equal to my model.predict method that is going to be requiring a list of, I don't know, let's go with something like 33. All right, that's basically my code. And then kernel is going to be linear. I'm going to go with controller, control C, control S, grab plot out here, paste it, and then say something like, let's say I was sort of confused as to how is it that I need to write, let's say, write my data set. And what is it that I need to print? Let's go with something like to print. Besides, I don't know, besides prediction, BSIDES, PREDICTION. And let me fix my typo real quick here. Okay, and then I guess let's just go ahead and send it. Okay, stopping you here before you run this. There are real problems in this code, and you already sensed something was off, which is why you asked. Good instinct. Let's fix the confusion first. That confusion is, what is your data set supposed to be? Go back to the bouncer example. You had 2 pieces of information for every person: their age, their feature / input, which is X. I did add that stuff. And then whether they were a troublemaker or safe. I did not know how to add that stuff. That's it. I'm going to drink some water real quick. Okay, how did this bug get in my water? I am not drinking this. I'll just dehydrate myself to death. How did a bug manage to enter? I just opened it for a split second. It's not even a bug. It was just, I just saw something there. I don't know what was it. That said, you need the same structure here right now. You wrote X equals to a list of 9, 12, 18, 21, 25, 30, 40, 90, which are all in a separate list of their own. X is your list of ages. Fine, that's your feature. But Y equals to pass. Pass is a Python keyword that means do nothing. It's not a value you need. It's not a value you need Y to be a list of labels, one for every single entry in X, telling the model which group each one belongs to. Since your group have to be cleanly separable, no overlap, remember, you need to actually decide where your cutoff between fail and pass is before you write Y, because Y has to match X position by position. 2 real bugs to fix on top of the missing Y. SVC kernel linear is a typo. I spelled KERNEL. Kernel, not kernel. Not kernel. Okay, so it's kernel, not kernel. Scikit-Learn won't recognize kernel as a valid argument. You never printed model.support _ vectors _ the whole point of this exercise. Your job fixing these, decide your 2 groups clearly. Okay, how do I have 2 groups for my Y? All right, let me say something like, sensei, how do I have 2 groups? How do I separate 2 groups for my, let's say, Y variable? Question. My Y variable. Oh, let's think. How do I separate my 2 groups for my Y variable? Without, right? Do I need to use the string pass and pass or fail? And how would, oh god, what in the world am I doing? And how would the syntax look like? Question mark. Okay, let's see. Good asking before assuming on syntax you've never seen. That's the right move. Yes, you can use strings as labels. SVM doesn't care if your labels are words, zeros and ones, or anything else. It just needs one label per entry in X in the same order. Look at your X again. X equals to a list of 9, 12, 18, 21, 25, 30, 40, 90. You need Y to be a list of the same number of entries, 8, where each position tells you the group for that same position value X. 9 is fail. Oh, okay. Now look at your own line. All right, I think I got it. Okay, so apparently Y is going to be a list of my predictions where 9 I predict is going to fail. There we go. And then we're going to go with something like 12, which I predict is going to fail as well. And then we're going to go with 21, which is going to fail as well. Next up, we're going to go with 25, which is going to pass. 30 something that will be passing as well. Okay, and then 40 is going to pass as well. And lastly, 90 is something that is going to... Whoops. That is going to... Are you kidding me? Pass as well. Okay, and then once we're done with that, this is going to be kernel, not kernel. Model.fit xy, and then we have prediction equals to model.predict 33. I am going to predict is going to fail because of these center points here. Okay, and then we're going to print our support values as well. I'm going to print my model dot support underscore values underscore, and then we're gonna go ahead and print our prediction as well. PREDICTION. Now let me hit Control to save the code, and then tap Control / to get my terminal here. First things first, I need to be in my literal file path that I am currently on, which is Scikit-Learn. Therefore, I'm gonna change my directory to Scikit-Learn. Okay, and then I'm just going to go ahead and run my file. So I'm going to go with something like py. Oh my gosh. I'm going to go with py svm.py. All right, let's see. I guess I'll give it some time to think. I want to refill my water real quick after like cleaning it because I'm not drinking that water. Interesting. So I ran into an error. So validate underscore data xy. I saved my code. Support values. What is my main error that I get? Value error found input variable with inconsistent number of samples 87. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Fail. I need to add another fail. All right, okay, that was on me. That was my bad. Hold on, let me just go ahead and run this again. Okay, this time it should pass, but we get an attribute error. Support vectors. Okay. There we go. Now let's just go ahead and run the code again. Yeah, that was basically a syntax typo. Okay, so apparently our model.support vectors is a list of 21 and 25. That is correct. 33 is expected to pass. I'm gonna go with something like prediction underscore 2. That is going to be equal to my model.predict. That is going to be a list of 10. And then this is going to be prediction underscore 1, which I will be changing this to be something like prediction underscore 1. Okay, and then let me just go ahead and add another print statement that is going to say PREDICTION underscore 2. This is going to be my second prediction, which I'm going to go ahead and hit Control to save the code. And let's run it. All right, we're going to see both our predictions. Perfect. Okay, now let me just go ahead and copy this, grab Claude here, and then say output, which is going to be this, and then code, which is going to be my Visual Studio Codes' literal code. I'm going to copy that and then paste it. And then let's just go ahead and send it. Okay, you ran it, you fixed the typo. But built valid Y labels, and you even added a second prediction on your own initiative to test both sides of the boundary. That's real ownership of this exercise. Nobody told you to add. Prediction underscore 2. Let's read our actual output carefully because it confirms everything it builds by hand. And I will be checking if my recording is still going on. There we go. Because yeah, I am kind of recording this stuff while streaming as well, because streaming does decrease the quality a lot, but recording does keep the quality really good for my code with me's. That's it. Support vectors 21 and 25. Look at your data. 9, 12, 18, 21, 25, 30, 40, 90. Label fail, 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 pass, 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 pass. The biggest gap in your data is between 21, last fail, and 25, first pass. Just like the bouncer example, 20 and 25 were the closest points from each group there. 21 and 25 are the closest points from each group here. The model completely ignored 9, 12, 18, 30, 40, 90. Exactly like it ignored 12 years old and the 90-year-old earlier. Only the two closest point matters. Okay, that does make sense. Prediction. Quick check before we move forward. A real number. Use your actual output, not the bouncer numbers. Using 21 and 25. What's the actual decision boundary, the cutoff number that SVM landed on here? Same math you did earlier with 25, with 20 and 25. Okay, using, wait, so what is, I need to grab my calculator for this. Hold on a damn minute. What is 21? Oops. What is 21 plus 25 divided by 2? 23. So 21 plus 25 divided by 2 equals to 23. Wait, did I? Divided by 2 is 23, yeah. 23 is the bouncer point. Correct, 23, you just rederive the exact same calculation from scratch in your own data set using your own real output. That's not memorization. That's the concept actually sticking. Quick recap of what you now have. Fully verified against real code and real output. SVM finds the boundary with the widest margin between two groups. That margin is defined only by the closest from each group. The support vectors, you confirm this yourself. Your support vectors were 21 and 25, and every other point, 9, 12, 18, 30, 40, 90, was irrelevant to where that boundary landed. The decision boundary itself equals to middle point between the support vectors equals to 21 plus 25 divided by 2 equals to 23. SVC kernel equals to linear straight line boundaries, same shape as your bouncer cutoff. Dot fit slash dot predict, same surface as every model you've used before. This is kernel equals to linear, fully closed, cleanly separable. Okay, I guess we're done with the kernel equals to linear. There's a messier layer, what happens when two groups overlap and no straight line cleanly separates them, but that's a real fork in this road, not a small addition. Want to keep pushing into that overlapping data case right now, or lock in a stopping point here for today? I can keep pushing because it's literally just been 2 hours since I started streaming. And my mind I feel like my brain is getting much better at, let's say, remembering these things. Well, not remembering, I think the anterior mid-cingulate cortex is expanding, which basically means I can get to learn or understand more topics than I could, let's say, a month ago. That said, you said you can push, good. You know what? Screw it, I'm gonna get some water. My throat is killing me. That said, I've got 8 minutes on clock, but give me a quick second. I'm gonna fill my bottle and I'll be right back. testing, mic testing. Okay, perfect. Let me go to my main camera. I mean, my gameplay screen. There we go. Okay, we're back. Let me drink some water. My god, I'm way too thirsty out here. Okay, wait, hold on. There we go. Okay, you said you can push, but let's be precise what's next, because this next concept is a genuine escalation, not a small add-on. No easing into it, full attention. The problem, what if there is no clean gap? Everything so far assumed your two groups had a clear gap, like 21 and 25, with nothing in between. Real data is rarely that polite. Numeric example, same hour studied setup, but now messy. Failed 15, 18, 22, 28. Passed 20, 25, 30, 35. Oh wow. Look closely. 22, a fail, is higher than 20, which is a pass. There is no clean gap anymore. The groups are tangled together. If you try to draw one straight line that puts every fail on one side and every pass on the other side, you literally cannot do it. No number exists where everything below equals to fails, everything above equals to pass holds true. So what does SVM do when perfect separation is impossible? It stops determining perfection. Instead of find a line with zero mistakes, it shifts to find the line that gives the best margin. Of course, every single machine learning topic that I work, they find the best answer or the best conclusion as opposed to the perfect conclusion, if that makes any sense. Best conclusion with the available resources that they've got, while accepting what a new few points might end up on the wrong side or too close for comfort. Hold on. Find the line that gives the best margin, while accepting that a few points might end up on the wrong side or too close for comfort. Okay. It's willing to eat a small number of errors on purpose if that produces a wider, more stable margin overall, rather than twisting the boundary to a fragile shape just to force zero errors. That's a parameter that controls exactly how much model is willing to tolerate. This is how strict versus forgiving it is about. This? Wait, hold on. That's a parameter that controls exactly how much the model is willing to tolerate this. How strict versus how forgiving it is about points crossing the line. Oh, I see. That parameter is called C. Before I explain C mechanically, gut check based on only what I told you. If C controls how strict the model is about tolerating mistakes, what do you think happens when C is very high, strict or forgiving? And what about very low? If C is very high, then the model will not be forgetting at all. However, if C is comma, right? No, if C is however, if C is being very low, BEING, there we go. If C is being very low, then the model will be forgiving almost everything. That was a guess. That was a guess. Fact check me. Okay, and then I'm just gonna go ahead and send it as soon as I fix my typo here. There we go. Okay, that's correct, and it wasn't really a blind guess. That's you applying logic from the word strict itself. Let's fact check it properly and make sure the reason behind it is solid, not just the direction. High C equals to strict, low tolerance for mistakes. The model gets obsessed with classifying every single training model correctly, even if it means shrinking the margin down to something razor thin and fragile just to squeeze in one stubborn point on that right side. Think of it as the model saying, I don't care how uncomfortable the boundary looks, get every point right. Low C equals to forgiving equals to high tolerance for mistakes. The model is fine letting a few points sit on the wrong side or too close to the boundary as long as it gets a wide, stable margin overall. It prioritizes the big picture over nailing every single point. I think I see. The model is fine letting a few points sit on the wrong side or too close to the boundary. As long as it gets a wide, stable margin overall, it prioritizes the big picture over nailing every single point. Here's the part that matters most, the actual trade-off. High C isn't automatically better just because it's stricter. A model that forces itself to classify every training point perfectly can end up overfitting, bending itself around noisy or weird one-off data points, which makes it perform worse on brand new data it hasn't seen. Sound familiar? That's the exact same overfitting idea you already ran into with ridge regressions and high/low alpha. Quick connector, since you already have this framework from ridge, in ridge high alpha crushed the weights towards 0 and made model simpler/safer. In SVM, does high C make the model simpler/safer or more complex/aggressive? Wait a minute, I think I need some water before I really go with that, because I am sort of reaching my limit, not there yet. Matter of fact, I may continue this. What was the topic? High SVMs or something? Okay, that was linear regressions. I may work on this next regressions next stream. That said, 2, 1, and that's time. Hands off anything that is not distracting. Let's move on back to Wuthering Waves. Yeah, I think I was kind of at my limit there. That said, reconnect Sonodisk. So I'm gonna reconnect my Sonodisk here. Alright, we need one more, I guess. The water level is going even lower. Wait, almost to a point that there is no water.
Now the water is all gone.
Oh, it's all gone.
One last note to go.
Alright. So apparently we... Oh, we go down. Oh wow, we go real down. There we go.
This is the last one. They've prepared quite the welcome for me.
Oh, hell no, moving on. Whoa. I'm so glad I freaking upgraded my Rebecca. She's a beast. That's a massive Tacit Discord. Oh, hold on a damn minute.
Pounding on you.
Embracing change.
Embracing change, yeah. That was a massive Tacit Discard. Or was it a
I have the last Sonodisk ready. Time to go back to the Symphondai.
Alright. Where is it though? Oh, there we go. Okay, so we get a path here. I'm gonna just follow this. Alright. The door is already open. F to go up. Okay, so moving up. Okay, F to go down, but I think I need to go straight, right? Okay, we're gonna open the door. And that's pretty much... Oh, don't get me, no. Alright, that's... Ouch. Alright, let's reconnect the last Sonodisk. All 5 have been connected.
Now I should have access to the database.
Guess we're getting access to the database here.
Well, let's take...
I wish I was a bit faster. Head to the database. Check the database for more information. Alright.
So this is the Grand Library. It's said to hold the answers to every question imaginable. I'm not seeing anyone here.
Is that
I guess the
Chinese or
magistrate is yet to
Japanese?
arrive. Well, it wouldn't hurt to browse the archives for a bit as I wait for her to show up.
Alright.
Thank you for leading the way.
Ignore the
Rover.
timer.
What a magnificent place to set
Why did you
foot
not
in.
add my Blockman to account yet?
Extensive, exhaustive.
Pretty
Oh, how I
scar.
want to carve the place inside out and blow it all to shreds.
SS,
Thought you'd
message
seem a
me
bit
on
more
my Discord's
surprised.
gaming chat. I'll add you after the
I
stream.
wonder
Yo, hiding
why.
Longster, appreciate you joining the stream. Oh, wow. I can't believe I missed the peak.
So you've laid a trap for me.
Oh? Damn, Scar's...
Interesting. Do you really think you can trap me here?
Uh-oh. Scar was the
You will not
storyteller.
escape.
What a shame I can't stay and play with you a bit longer.
The timer
Till
is
we meet
messing with my
again,
experience.
dear friends.
You're not going anywhere.
You're not going anywhere. Alright, moving the timer away. Let me get this timer away. Quest reward. Oh wait, we gotta fight Scar? Oh my gosh! I was already... Get him, boy! Damn it.
Embrace things.
Special
change.
move! What a match
Steady
this is.
there. Counting on you.
Oh wow! Wait, Scar actually has a lot of health. Oh god, he has damage too. I'm so glad I upgraded my... Oh.
Embracing change.
Bracing change. You can't even see him.
Counting on you.
Counting on you. Yeah. I want to show you guys my R ability here. That's so good. Get him, boy. I want to show you guys my R ability. That's why I'm not switching. Bro, Rebecca is insane.
Shut your stinky pie hole!
What?
Go get him, bud!
What'd you just say? Alright, I'm taking real damage. Hold on, I'm taking real freaking damage.
Stay, leave it to me. Embracing change.
Racing change.
Go get him, bud!
What's this?
Eat less, loser!
Eat lead, loser!
Open wide!
Open
Pay
wide.
for my chrome! Ow!
Did I spam F? Oh! Too smooth, what I'm saying! How many GB is this game? Oh, don't even ask. Please, it's more than 100 GBs. I think I need to check because it keeps saying me to add GBs. I know it's way more than 100 GBs.
Did you just offer
He's in his
yourself up
nightmare
to be
form?
my
I'm almost dead.
Now, it's just the two of us. Still away that irrational anger.
Oh, wow. Alright guys, ignore the timer. I'm pretty much done with my today's work, so I'm just gonna complete this before I move on.
Seeing is not always believing. Why are you so sure they told you?
Rebecca, if I get Rebecca's
Don't
ult
jump to
again, this is
conclusions
over.
so
It's not really
soon.
over, but I was just saying to cope.
Why are you so stubborn? Why can't you place some of that trust in me? Or do I have to crush you to make you behave for once?
Wait, how did I heal? Wait, how did I heal? How the hell did I heal? We may be Gucci, what the hell? I'm button mashing the frick out of everything. It's o'clock! There we go! Bro, Rebecca is such a freaking badass, what the hell?
I got your back.
Got your back! Oh!
Embracing change.
Embracing change.
Do your work, flathead! Shut your stinky pie hole!
Perfect.
Counting on you. This is my ground.
This high ground.
Embracing change.
Embracing change.
Lightning bang!
Bro, Rebecca is so good when it comes to attacking. She's not even the best attacker in the game. I'm out of stamina. That's what what was causing the issue here.
You got me there.
No, I got trapped. Wait, I didn't die?
Embracing change.
Can I absolutely? Well, there we go. I'm gonna exit this. Wait, did we beat Scar? Oh. We did beat him. Oh wait, what?
So you knew I was following you all along, huh? My Elysium only breaks under coordinated attacks from both sides. I can never get rid of all these pesky little helpers around you, can I?
Oh, I see.
So you've joined hands against me with Miss Magistrate here. It does hurt my feelings, you know? You're always so popular.
Average anime character.
Are you all right, Rover?
I'm fine. My throat is not fine after all that hyping up.
Of course he is. How could I ever have the heart to hurt him? Consider my moment of failure a gift of sincerity, Rover. I trust you haven't forgotten our conversation earlier?
Machine learning or Genshin Impact, gang, you lost your focus? Actually, no, I am following a 25 to 5 minutes as Pomodoro, where every 25 minutes I get a 5 minutes break, and every 4 sessions of 25 minutes I get a 15 minutes break. Although I did reach my limit today, so today, before I was going to be wrapping the stream up, I wanted to complete the storyline so I don't really lose my progress. But I think the main goal of the stream is over. I'm not going to be working anymore.
I'll tell you everything you want.
I was just waiting for this to get over. I already know everything, but I think Scar is not an enemy here.
Huh.
Also, it's Wuthering Waves.
So she made the move before I could, and told you all of it already. Then as the winners, would you be so kind as to tell me how you set me up?
Alright. It's always these cutscenes that are so freaking long. Watch there be another cutscene. Wait, can I just exit now? Because I do have college work to get done as well. I can't really... First meeting.
Now I have retrieved the magistrate's message for me from the puzzle box. But it only points me to the Grand Library. There's no meeting time. Something... I've solved the puzzle. The discs have been rotated, and the 2 symbols are now glowing. With this glowing light, a shadow is cast onto 2 other symbols. The black tortoise of the north to the city hall.
We're still trying to find Yang
the
Yang.
kitchen of Cho, in the wee hours of the morning.
This is what it was with Yang Yang. Wait. Is it over?
It's been
Of
3
course.
days. We both made it on time.
Or cutscenes?
Allow me to formally introduce myself. I am Jinshi. It brings me great joy to see you, Rover.
Alright. Hello? Why wait 3 days to meet me in person? Did something happen? I hope I'm not taking another rejection. I'll go with... that.
To show up as a projection again would be ill-mannered of me.
Mm-hmm.
Please rest assured, it is a real human in the flesh you're speaking to. Despite
Alright.
Huang Long's advanced technology, such realistic projection is still impossible. Or perhaps you would like to verify it?
Exactly how? Jinchi smiles genuinely and offers her hand to you, radiating calmness and sincerity. Alright, shake her hand. Alright, it is a real person. Are you injured?
It is nothing to be concerned about. An emergency forced me to leave, and I only had the time to prepare some tokens for you. Please, pardon my lack of hospitality.
Alright. Does the emergency have something to do with the Fraxidius? Does the emergency have something to do with the with your sentinel? I'll go with your sentinel.
Yes. The Sentinel of Jinzhou is currently absent.
Aren't they supposed to stay in their domains?
Correct.
Dude, I want to actually
The
leave. I'm
Sentinels
exhausted.
guide and guard humanity as a symbol of our civilization. When a region's sentinel goes absent, chaos is bound to ensue. As this news could lead to civil unrest, please keep it a secret.
Alright.
Jinzhou's sentinel Jue is being held captive by the Fraxidius. I had to postpone our meeting and put all my effort into finding its whereabouts.
So it's Fraxidus and not Fraxidius. I heard you can resonate with the sentinel.
Yes,
Interesting.
our thoughts are connected, to a certain degree. I can sense its memories, feelings, and surroundings, though not very clearly.
When is this gonna end? Have you found it yet?
Unfortunately, I haven't. I can feel Jue is in danger. The good news is, I have figured out the culprit behind all of this.
Is it Scar?
Precisely.
Pretty sure not.
The
It is?
Fraxidius plans to advance another lament and cause disasters worldwide. Overseer Scar had several objectives upon infiltrating Jinzhou. To track you down, to test your strengths, and to make you join their cause. To abduct Jue and to resurrect the Threnodian in advance.
This is so long I wanna exit. Why me?
They must have discovered your value, likely from one of Jue's prophecies. If you join them, they'll gain significant power.
I see.
Should you refuse to join, the Fraxidius will likely want to eliminate you, so you don't get in their way. I have a plan to apprehend Scar. Once we capture him, the Fraxidius won't be that much of a threat to you for the time being.
Oh, so this is basically the backstory before they went and fought these Scars, so
If
it's
you are
almost
willing
over.
to lend us a hand, I will ensure your safety during our cooperation.
Alright. And is it almost over? Count me in. I have some. Can I have some?
Thank
Okay,
you
count
for
me
your
in.
trust, Rover.
Alright.
Speaking of which, you seem to have already gathered a lot from the tokens.
The mangosteen points to how people lived through the wars in Jinzhou. The sugar pearl points to past epidemics and disasters. The leaf points to the Fraxidius. The sundial points to when and where we're meeting. I don't know what they mean. I'll just
Impressive,
go with the
Rover.
first one. And I learned more about my identity as I deciphered the tokens.
The threat Jinzhou is facing is far worse than meets the eye. One of the Threnodians will soon be reawakened.
What are the Trinodians? Oh wow, we're getting another
They are
whole
the
lecture.
enemies of human civilizations, born from the dark side of our collective consciousness. We must defeat them to protect all of humanity.
Okay.
We have been doing our best to prevent the disaster, but the Fraxidius is accelerating the Threnodians' revival.
And it has something to do with me. Yes?
Indeed. You have defeated the Crownless and absorbed its echo with your bare hands. It is the tacit discord that embodies the concept of warfare. Resentment of the fallen, fright of the ignoble, those are the emotions that lay ground for its birth. The Crownless is a tacit discord that possesses powers from the reviving Threnodian.
And a shiver runs down my spine.
Jinzhou is a border city with an unbreakable will and a strong spirit of resistance. However, we also fear the constant wars and loss of life, and the Threnodian can prey on that. You, however, you were able to defeat and absorb a Threnodian-related tacit discord with your bare hands and resonate with other TDs. Meanwhile, Huanglong's records mention a hero with similar powers who saved our nation during the Threnodian War. He is mentioned in literature dating back to Jinzhou's establishment.
I feel like this backstory is as long as an average anime episode.
To uncover your true identity, this could be a helpful lead to pursue.
You believe that person and I could be related in some way?
Yes, based on my own deduction, and the prophecies of Jue.
Jue? In the Georges of Spirits?
You mean... the unfinished statue of Jue?
I remember something when I saw it. I'm not sure if that's really what happened. I'll go with I remember something when I saw it.
I see. Do you mind letting me know what you remembered? Since it's related to our sentinel, I might be able to help.
You tell Jinji about the fragment memorized... Okay, I gotta read the
Rover.
whole thing.
The memories of which you speak,
Yes, anything worth noting about them?
as I mentioned earlier, I can resonate with Jue, our sentinel. Your recollections, they align with what I've witnessed in Jue's memories.
Oh?
Yes, I do remember seeing something similar. I believe it had truly happened in the past.
In other words?
In other words, you may be the person mentioned in our records.
Oh?
The unwavering presence by our sentinel's side, bonded by an unbreakable trust.
I don't recon resonators can live that long.
Resonators tend to live a longer lifespan, but it is indeed unprecedented to live hundreds of years without any sign of aging. So many mysteries about you remain unsolved, and your age is just one of the unknowns.
If this is true, who saw... Okay, if this is true, who was I all that time ago? Then how did I end up losing my memories? This is what I want to know.
Sorry, but I don't know. Jue's last piece of information pointed to the Northfall Barrens, where you should find the Threnodian.
Alright.
I pray you will find your answers there.
She has a tacit mark as well.
The Threnodian is resurrecting,
It's
and
still
our
going.
nation is in grave danger. This reminds me of the Threnodian War all too much. Perhaps this has something to do with your mysterious appearance in Jinzhou.
You mean I showed up to protect Jinjo like the historical hero did?
Not really. I don't plan to believe in a hero showing up out of nowhere and protecting us. I'm just presenting whatever lead I have about your past, as I know it is
Alright.
troubling you. I want to help you, and that is all there is to it.
When is
Thank
it
you for
getting over?
considering lending us a hand. Your help is much appreciated. But please, do not feel obligated because of the information I shared. They are my people, and the responsibility to keep them safe should fall on no one else but my own shoulders. I
The
am
worst
saying
thing
this
is I
because
can't
I have
cancel
faith
this.
in my abilities, and even more so in the bravery of Jinzhou soldiers and our people. You deserve to make your own decision about this after uncovering your true identity. I appreciate everything you've done for us during the past few days, and perhaps even longer ago. Once it all settles, I am ready to accommodate and assist in whatever future decision you make. You can leave Jinzhou, or the entire Huanglong if you wish. If you ever need me again, you need only ask. Let's keep this a secret between the two of us. How does that sound?
Okay, even if it was kind of awful to stay this long for this storyline that I could have, done something more productive about college work for, I think this was so worth it. I enjoyed the story. I predicted that it's gonna end there. What the hell? How did I... That was the perfect ending, Mark. I didn't even know that it was gonna end. I thought we would have more
Scar,
conversation.
You are
There we
now
go.
under arrest for committing multiple felonies in Huanglong. Do you have anything to say?
What do I want to say, huh? While I'd love to tell you another story, I guess that's not what you want to hear. Let's cut to the chase, Madam Magistrate. I'm getting bored already.
Very well. You will answer only our questions from now on.
Sure, why not? What do you want to know?
Why did you kidnap Jue? Why are you obsessed with reviving the Trinodian? What on earth is the lament? Why are you following me? I'm done with him. Since I want to go, I'll go with I'm done with him.
You kidnapped Jue and revived the Trinodian, accelerating the next lament. This is proof enough that you are the enemy of Jinzhou and all humanity. Stop dreaming you can force Rover to join you. He is our honored guest, and I will not allow any harm to come his way.
I thought Scar was Rover's ally before Rover lost his memory and that he was trying to help Rover recover his memories. Nope, he's trying to use Rover.
How confident you sound. As the Trinodian's resurrection
you sound.
approaches, Jinzhou is barely holding on.
Barely
How
holding on.
much longer do you think you can keep up this facade?
Thank you for your concern. We have crushed your schemes once,
Why
and
is
we
he
can do it
facade?
again.
I'm so confused. Who is here trying not to use Rover besides Yang Yang?
I have one last question for you. Abducting Jue, stalking Rover, and setting up an ambush in Cheecher village. You couldn't have accomplished that all on your own. Unless...
More conversation.
Unless I'm not the only overseer in Jinzhou, right? I have answered all your questions with full honesty. I don't mind you knowing because it won't make any difference. You can try to stop us with all you
Is
have.
he gonna break his skull?
But it's too late to change the course of history. Now, I have one question for you. You seem convinced we caused the disappearance of Jue. What if I told you
Jue.
there was more
Crunch.
to it? Would you
about Jue. What else do you know?
When is this gonna end? I gotta go.
come closer and I'll tell you, Madam Magistrate. It's a secret for your ears only.
Interesting.
How dare you?
How
Madam
dare
Magistrate,
you? Wait, what is he saying?
No. It can't be.
It can't be.
Shocked, aren't you? But there's more.
What else?
What if I told you your sentinel had made this prophecy a long, long time ago? Your all-seeing sentinel abandons you now, of all times. Need I say more?
What did he say?
We're merely adding a touch of extra fuel to the fire that will soon consume all.
Wait, what?
Rover, care for a wager? I know you've been searching for answers about your past, and I've got news for you.
Oh,
Watch out!
watch out! The card
You
slips out
are
of-
one of us, the Black Lambs, and you
How
have
is
been
this-
chosen to join us, ushering in the new world.
I got
Once
goosebumps
you
when that
discover what
happened.
you really are, you will come to us with no hesitation.
You guys wouldn't know about the Black Lambs. That was in my gaming channel.
The Fraxidus awaits your arrival with open arms. And I look
The
forward
slow
to that day
motion.
in sincere
It
anticipation.
courses every inch. And then an explosion? That's the Black Lamb story. That's the whole reason I gave Scar the title of a storyteller. After the interrogation, Scar is put in jail. Is it over? Am I free to leave? Not, of course not. I'm stuck here. What did Scar tell you?
Sorry, Rover. What he mentioned about our sentinel is highly sensitive.
Hmm.
I cannot disclose it yet. Not before verifying it myself. Is it a ploy to create distrust among us? Or
How
I must
important
first
is
find
it?
our sentinel to uncover the truth.
How important is it, Yue to Jinzhou?
Jue is the guardian sentinel of Jinzhou. It is responsible for assisting Jinzhou's magistrate in administrative affairs.
This is so long.
While I am the final decision maker, without the assistance of Jue, I cannot guarantee I am always making the best choices for my people.
You seem to be doing well enough on your own. Why are you not sure Jue is always right? Why are you
Thank
so
you.
sure?
I am glad you think so. Jue can predict the future, and up to this point, every one of its prophecies have been proven true. While justice may not be universally agreed upon, its decisions have consistently served the best interests of Huanglong.
Perhaps it left to set Jinzhou's future right. Perhaps it intended to let you make your own decisions. I'll go with the second one.
For that,
But I gotta go. Why
I
is this taking
suppose
so
we will
long?
have to talk to it in person to find out.
Alright.
In addition, Rover, Jue once told me to deliver a message to you. To the Awakened One. When raindrops fall upstream, please head to the Northfall Barrens and seek General Jian of the Midnight Rangers.
Okay, this is such an entertaining gaslighting for me. Like, I gotta leave, but this is going on for it's been going on for the past 16 minutes. So, I need to find the General Jian. So, I'll need to go to the Northfall Barrens. I'm gonna go with this.
I suppose so. General Jian is currently battling another TD outbreak in the Northfall
Oh, wow.
Barrens, which will also serve as our front line against the Threnodian.
Alright.
But the ongoing war has made it a very dangerous place to go.
I just realized I gotta use the restroom as well, to be honest.
Since you won't need to go there right now, not until when the raindrops fall upstream. I know
Alright.
you're here for clues about your true identity. And I don't want you to leave the city empty-handed. Have you heard about the Black Shores, Rover?
There's
It's
more.
an organization shrouded in mystery, with a secretive membership process and members who usually keep their identities hidden. Upon your awakening, one of their members discreetly contacted me to gather information about you. But please don't worry. The Black Shores developed a special lament prediction system and has established partnerships with countries worldwide.
Alright.
While operating in secrecy, they are not an extremist group like the Fraxidus. They have been monitoring the situation in Jinzhou to provide assistance when needed. Thanks to their extra help, my meeting with you went smoothly. This Blake
Is it
Bloom
over?
is their symbol. The Black Shores members usually wear it on their person.
What do they want to achieve in Jinzhou? There sure are a lot of people keeping an eye on me. Wouldn't that make them easy to spot? Alright, I'll go with the easiest answer because I need
Rover,
to leave.
After the recent series of events, I trust you have gained a general idea of who you might have been.
I mean, yeah.
Before you fell into that deep slumber,
Uh-huh.
you likely played a significant role in important historical events, shaping the course of history in some way.
I see.
Ultimately, I suppose it is up to you to discover the final definitive answer for yourself. This photo is yours to keep. I will return with Jue shortly, and the Black Shores may be worth your try during this time.
Please tell me it's over. Of course it's not. Of course there isn't more. When is this gonna end? I need to leave. I got an assignment tomorrow. Alright, let's see. Is it the Sentinel?
Rover, are you all right?
Was that a vision? A deja vu? I saw something. I was wearing the Blake Bloom.
I see. The Black Shores must have a deep connection to your past. Since you are likely being closely monitored by the Fraxidus now, I suggest keeping an eye out for the Black Shore members. They could prove to be your valuable allies. I'll do my best to find Jue and tell you everything I learned from it once I return.
Alright.
This is my promise.
I'm counting on you.
Yes.
Is it over?
Please leave it to me.
I will. It's all on you now. I'm leaving. I'm leaving. Is it over? No more cutscenes? No more communications? Of
Sanhua.
course there's more.
Yes, Madam Magistrate.
Huh.
I will be going on a temporary leave.
Okay.
During my absence, please help me handle my responsibilities in Jinzhou.
Understood.
She like a
Should I
personal
continue
assistant?
protecting that rover?
No need. Both Chan Li and I will be away, and there will be more than enough paperwork for you to handle.
Is Lady Chong-Li leaving for the capital? Please pardon my intrusion, but he just faced an ambush in the Central Plains. What if...
Regarding that incident, we tried to warn him about the Fraxidus, but they were more cunning than we thought. If he runs into another powerful enemy like Scar, he'll eventually have to confront them on his own. Sanhua, you can place more trust in Rover and me.
Alright.
Understood.
Oh, her eyes look
will.
kinda cool.
My lady, no matter what happens, my sword is always yours.
Both the interrogation and my appointed meeting with Rover have already finished.
Scar only needed the two of you as his audience.
Wait, who
We
is
already
she?
knew what he wanted, and we let him have as much.
He decrypted every message we intended to convey. It's only proper you meet him in person, as the one who crafted those puzzles. Such intricate puzzles. I guess only Rover has the patience to solve them all.
No detail is too small. I'm sure he understands. Besides, not seeing the opponent heightens the thrill of the game.
It
If
kinda
everything
does, to be
goes
honest.
according to the prophecies of Jue, I will meet him in person eventually.
This never ends.
So, what did our captive from the Fraxidus tell you about Jue?
There's more?
That Jue had predicted I will have to fight it one day. A fight that will shape Jinzhou's future.
Well, that is unexpected. But you don't seem all that surprised, do you?
Can't say I am. I had suspected as much from our previous conversations, and the message it left me, his words only confirmed it.
Where was it when you last sensed its presence?
It was in Mount Firmament. Unlike Jinzhou City, that mountain is still resting in stillness.
The place where the first people of Jinzhou lived, and where Jue first manifested before us humans. I see.
I'll find Jue and bring it back as soon
Is
as
she
possible.
talking with the Sentinel?
Our enemies could have planned it as a trap. We have a
Alright.
bigger goal to focus on, remember?
Remember?
I understand. I will not let anything or anyone disrupt the peace in Jinzhou.
Would you let what you heard from Scar sway your determination?
No. He cannot ever turn me against Jue. If
The
anything,
Sentinel.
his words only confirmed my theory. I am the magistrate of Jinzhou, appointed by the Sentinel itself.
Interesting.
The prophecy speaks of a decisive incident for Jinzhou's future, where I will be a key player. The fight between me and Jue is only a precursor.
I'm gonna tweak out real soon if this doesn't get over. I gotta use the restroom and I have a lot of college work. This never ends.
My job remains unchanged. I will fulfill my duty as Jinzhou's magistrate with my...
Is that your
On my
final
own judgment,
answer?
my bad, I skipped that by mistake.
A single strand's neglect births mountainous upheaval. You taught me that, remember? The safest option is for me to go in person.
Very well. Since we are already mid-game, I will let you decide our next move. This time,
Who is she?
I shall be a pawn in your hand.
Is she Jue?
Remember, I will always
It's
stand by
Zhongli.
your side. In this crisis, or any other.
Is it over? Please tell
Am I
me
a
it's
player?
over.
Or a mere pawn? I suppose there is no difference at this point. No matter what, I will do what I must.
Is it over? Please tell me I can leave. Let's go, the clashing badge. I can leave, right? No more cutscenes. Oh gosh, hold on. I don't want to jinx it. I jinxed this twice before. Wait a damn minute. That's pretty much good. Okay, even though it was awful, that's it. I can exit. Rewinding raindrops. I got my next badge. Let's go, let's go. Tower of Adversity. I got my third badge as well. New function unlocked. And 100 asterisks. Okay, perfect. That's pretty much it. New trophy, Whispering Melody. Let's go. Alright, Union level. Alone in the Abyss. New quest unlocked. Alright. Okay, I'm gonna go ahead and move on to my OBS now. By God, that took way too long. Alright guys, so basically that was pretty much it for the stream. The ending of the stream did not go as expected. I was going to be taking a 5 minutes break, then moving on to, let's say, some of my college work. But the story went longer than an average anime episode. That was pretty much it for the stream. If you guys did enjoy the stream, don't forget to smash the like button, subscribe and notifications turned on. And if you guys did enjoy my content / stream / video in general, make sure to share my channel, because like helps my algorithm sharing, makes you smile, and subscribe link at your top. That said, I did start multi-streaming. However, I will start multi-streaming in several platforms such as Twitch, Kick, YouTube, Instagram, TikTok if I did meet the followers requirement, or that if I found a way to stream without affecting my stream quality. That's it. If you guys do want to follow me in my socials, you guys can get access to my socials through the link in the description, through my bio, or by typing exclamation and the name of the social on chat. I'm kind of in a rush to really show you guys everything manually like how I usually do. I will do that from next stream. Although, if you guys, let's say, I did create 2 brand new channels, one called Viv Arcade and the other called Viv Workside. Viv Arcade is specifically meant for my gaming content, and Viv Workside is specifically meant for my workout content. Therefore, if you guys are interested in either one of those genres or categories and that you guys want to follow me there, you guys can get access to both my channels. Let's say through the link in the description. Actually, you know what? No point being lazy. Let me show it to you guys myself. Hold on, let me just open my channel real quick. Yeah, you guys can get access to both my channels through my homepage. If you guys scroll all the way down, I will be having both these channels featured, where I do upload videos daily in my gaming channel, and I don't know much about the workout channel. I do squat and that. Although you guys can follow me there. And about these socials, you guys can get access to all my socials through my bio or through the link in the description of my video here, and also by typing exclamation and the name of the social on chat. For example, exclamation Discord, or lowercase no space. If the social does exist, a link is gonna pop up. If the social does not exist, a link will not pop up. That said, if you guys do want to join me in my AI engineering for 365 days series, and that you guys want access to the roadmap that I am currently using for the series, you guys can get access to that roadmap through my Discord server. If you guys do join my Discord server, either go to the Coding Helps Us chat, the general chat, or the Python chat. Mention my name there, asking me for the roadmap. I will be personally DMing it to you guys, exactly like I did for multiple people here. Let me give an example. I'll probably go with this. There we go. Okay, and that's basically pretty much it. I did show you guys how you guys can get access to my, let's say, Discord and all my other socials and all that good stuff. That said, I'll catch you guys next live stream or video. Peace. And this went too long today. By God, that was so annoying. That's it. Let's end the stream.